Hello, and welcome to the Snoozy Scientist, where life's strangest secrets come alive, one gentle yawn at a time. Tonight, we're drifting into a question that has kept scientists, philosophers, and dreamers awake long after the rest of us have drifted off. What if everything you see, your cozy bed, the trees outside, the endless galaxies overhead, is nothing but a coded dream? What if the warmth you feel, the thoughts you think, the people you love are all part of an endless program playing out behind the scenes? What if you and I are not truly awake at all, but characters inside a vast simulation, watched by something or someone far beyond our understanding? It sounds like science fiction, but the world's greatest scientists have asked the same thing. Albert Einstein once reminded us, reality is merely an illusion, albeit a very persistent one. Richard Feynman, one of quantum physics' brightest minds, famously admitted, "I think I can safely say that nobody understands quantum mechanics, because reality at its tiniest scales makes no sense at all." And today, thinkers like philosopher Nick Bostrom argue that if advanced civilizations ever build realistic simulations, we may almost certainly be living inside one ourselves. Strangest of all, some physicists are searching for ways to test it. They wonder if the quirks of quantum physics, particles that vanish, reappear, or know when they're being watched, are little glitches in the cosmic code. Maybe reality is more like a video game than we've ever imagined. And before we wander too far, I'd love to know, where on this planet are you listening from tonight? Drop a comment and tell me what time it is where you're winding down. And if these sleepy rambles help you drift off, please tap like and consider subscribing. It keeps this little snoozy corner of the internet alive, and it means so much to have you here. So take a slow, deep breath, sink a little deeper into your pillow, let your thoughts drift like starlight, because sometimes the strangest dream of all is the one you're living right now. It really does sound like the plot of a late-night sci-fi movie, doesn't it? A world where nothing is quite as it seems, where you wake up each day, pour your morning coffee, look out at the sunrise, and trust that everything around you is solid and real. But what if, just behind that beautiful sunrise, there is a hidden layer you can't see? A layer where reality is not made of atoms and molecules alone, but of something more like a cosmic script running quietly in the background. For most of us, these ideas feel like bedtime stories for adults, strange dreams we set aside the moment the alarm clock rings. But some of the greatest minds who ever lived could not let this question go. They wrestled with it over late-night notebooks and blackboards filled with chalky scribbles. They peered into telescopes, built giant particle colliders, and scribbled equations that wrapped around the edges of their pages like vines searching for sunlight. The deeper they looked, the stranger things became. Physicists often say that the more we learn about the universe, the less sense it makes. Albert Einstein spent decades trying to make sense of it, dreaming of a single theory that could explain everything, the big and the small, the spinning galaxies and the flickering particles dancing at the edge of existence. He once called reality an illusion, stubborn and persistent, but still somehow an illusion. He meant that what we see, the world that feels so solid under our feet, may not be the final layer of truth. It may be just the surface of something far more mysterious. And then there's quantum physics, the branch of science that studies the tiniest building blocks of the universe. When you open the door to the quantum world, it is like stepping through the looking glass. Everything you thought was certain begins to shimmer and blur. Particles act like waves, spreading out into a haze of possibilities. They can be here and there at the same time. They can vanish, tunnel through barriers, and pop into existence from nothing at all. One of the strangest parts of quantum physics is that nothing seems fully real until it is observed. Imagine that for a moment. A particle might exist in many places at once, like a ghost of itself, drifting through space, but the instant you look, it chooses one path. This idea is known as the observer effect, and it has puzzled scientists for generations. Richard Feynman, who won the Nobel Prize for his work in quantum physics, once said that nobody truly understands it, not because scientists are careless or unwise, but because reality at this tiny level just does not behave the way we expect. When you look at a chair, you expect it to stay where it is, no matter if you're watching or not. But in the quantum world, it seems that nature only decides where something is when you check. If that sounds like magic, you're not alone. Some thinkers have begun to wonder whether this is more than just a strange quirk of tiny particles. What if this is a clue? What if, like a video game that only renders the forest once your character walks close enough, our universe only reveals its final details once a conscious observer comes near? This is where the idea of a simulation starts to take shape. If our reality flickers into place only when observed, it feels uncannily like the way computers save energy and processing power. In a video game, distant mountains are not fully drawn until you look at them. The moment you turn away, the game doesn't waste resources on every leaf or blade of grass behind you. It's efficient. Some scientists ask, could the universe be doing the same thing? Could quantum strangeness be a sign that reality at its deepest level works more like a digital dream? It is easy to dismiss this as pure fantasy, but the deeper we dig, the more the lines between science and philosophy begin to blur. The simulation hypothesis is not something every scientist agrees with. Far from it. Many argue that we have no solid proof, no way to peek behind the cosmic curtain and find the hidden code. But still, they keep testing. They build experiments to search for tiny glitches, patterns in cosmic rays, signs that the universe might have a built-in resolution, like pixels on a screen. Even if we never find the final answer, the question alone changes us. It invites us to look at everything with fresh eyes. It reminds us that reality is not something we should ever take for granted. The next time you look up at the stars, think of all the scientists, the dreamers, and the thinkers who stayed up through the darkest nights, wondering if this breathtaking sky is a masterpiece painted on a vast cosmic canvas, or a story written in a language of particles, waves, and maybe, just maybe, code. So tonight, as you sink deeper into your pillow, let that question drift through your dreams. Is this life the ultimate reality, or just a digital dream waiting to be explored, pixel by pixel, idea by idea, heartbeat by heartbeat? And would it change anything if it were? Perhaps the real wonder is that we get to ask these questions at all, and drift off under a sky that might be real, might be virtual, and is always beautiful either way. So, what does it really mean to say we might be living in a simulation? It sounds like something out of a late-night movie or a sci-fi novel you read under the covers with a flashlight, but the word itself is quite simple once you look closer. A simulation is a copy, an imitation that is so convincing, so finely detailed, that you cannot easily tell it apart from the real thing. It is like standing in front of a beautiful painting of a forest and feeling as if you could step through the canvas and hear the wind in the trees. You might not realize it, but simulations are all around us already. When meteorologists predict tomorrow's weather, they run computer simulations. These are models of Earth's atmosphere that use data, mathematics, and powerful computers to create a version of tomorrow before it arrives. Pilots train for dangerous flights inside flight simulators, special cabins that mimic the movement, sound, and feel of a real cockpit so perfectly that their muscles and minds believe they are really up in the clouds. Doctors use medical simulations to practice surgeries on digital or artificial patients. Scientists build entire virtual worlds to test ideas about how planets form or how diseases spread. In each case, the simulation is not the real thing, but for a moment, it can feel real enough to learn from, to practice with, to make mistakes safely. Now, imagine taking that idea to its farthest edge. Imagine a simulation so vast, so exquisitely detailed that every grain of sand, every drifting cloud, every secret thought in your mind is part of it, like pixels making up a video game, or lines of code telling each tree when to grow leaves, and each person when to laugh, dream, or cry. This is the core of the simulation hypothesis. It suggests that what you see, hear, and touch might not be the base reality, the original, raw world that exists without layers, but an imitation so perfect that you cannot tell where the code ends and reality begins. The thought is both fascinating and a little unsettling. If we truly lived inside a simulation, it would mean that your whole life, your thoughts, your memories, your dreams, your fears, all emerge from an invisible program, a system humming quietly behind the curtain of what you call reality. It does not mean you are not real. That is important to remember. Even inside a simulation, you feel, you love, you suffer, you hope, you build friendships, you sing in the shower, you watch the rain slide down the window and feel your heart stir at the sound. None of that is fake. Your experience is as real to you as anything can be. A character in a story does not know they are written in ink, yet their tale moves us just the same. Think about a video game for a moment. In a beautifully crafted game, a world comes alive on the screen. There are forests, mountains, animals, and people. Some characters follow simple rules, wandering down the same path every time you play. Others are complex, seeming to make choices, reacting to what you do. But behind every action is code, tiny instructions that say, if the player goes left, do this. If the player goes right, do that. The trees in the distance do not exist in full detail until you walk closer. The grass under your feet only grows when you need to see it. It is efficient, saving power and memory. Now, imagine that same idea, but on a cosmic scale. What if the stars do not truly shine in their full glory until we look up? What if the tiniest particle does not decide where it is until someone tries to measure it? This is the haunting echo in some quantum experiments. The observer effect hints that the universe behaves differently when it is watched, like a computer simulation that only draws what the player needs. Our universe might only finalize its details when we check. If that is true, it means there could be layers we cannot see, a hidden framework that holds up the sky, the oceans, the people you love. It might sound lonely at first. The idea that we are characters in a story written by an unseen author, but maybe it is not lonely at all. Maybe it means we are part of something bigger than ourselves, something woven together so perfectly that it becomes a stage for every possible story. It does not take away the beauty of the sunrise or the taste of your favorite meal. It does not cancel out the sound of your best friend's laughter. If anything, it makes them more precious, because even if everything is written in code, it is a code so rich and wondrous that it gives birth to every heartbeat and every dream. So tonight, as you drift off to sleep, hold that thought gently in your mind. A simulation is not a prison, it is a question, a chance to ask, what is real, and what does it mean to feel alive? And maybe, just maybe, it is a reminder that no matter what lies behind the curtain, your story still matters. You matter, pixel or particle, code or flesh. You are here, dreaming inside a dream, and that is a miracle all its own. And here is where quantum physics slips in like a mischievous ghost in the machine, peeking out from the corners of what we think we know about the world. Quantum physics is the science of the very, very small, so small that our everyday ways of seeing the world simply do not work anymore. It looks at particles so tiny that you could line up billions of them across the width of a single human hair. These are the building blocks of everything you see, from the pages of a book to the stars in the sky. Most of us grow up believing that the world behaves in predictable ways. If you push a swing, it swings back and forth. If you drop a stone into a pond, ripples spread out in neat circles. If you turn off the light, the room goes dark. These rules feel safe and steady. We trust that the universe will keep following them because it always has. But when scientists began to look closer, peering into the smallest corners of nature, they discovered that the universe does not always play by the rules we expect. In the quantum world, particles do things that sound like something from a dream. They can be here and there at the same time. They can pass through barriers as if they were ghosts. They can become entangled, which means that what happens to one particle instantly affects another, no matter how far apart they are. It is as if two tiny dancers perform a routine together, perfectly in sync, even if they are on opposite sides of the galaxy. Albert Einstein once called this spooky action at a distance, and even he found it deeply unsettling. One of the most famous examples of quantum strangeness is the double-slit experiment. Imagine you have a wall with two narrow slits side by side, and you fire tiny particles like electrons or photons at that wall. You might expect the particles to behave like tiny marbles, flying through one slit or the other and creating two neat piles on the screen behind the wall. But that is not what happens. Instead, the particles create a pattern of light and dark bands, an interference pattern that looks exactly like what you would see if waves of water were overlapping and canceling each other out. This means that each tiny particle acts like a wave, spreading out and passing through both slits at once, interfering with itself. It is as if the particle is in many places at the same time, exploring every possible path. But here is where it gets even stranger. When you set up a detector to find out which slit the particle actually goes through, the interference pattern disappears. The particle suddenly acts like a marble again, choosing just one path instead of all possible paths. It is as if the particle knows it is being watched, and the simple act of observing it changes its behavior. This is called the observer effect, and it sits at the heart of quantum weirdness. In the everyday world, observing something does not usually change what it does. Watching your cat does not make it vanish or split into two. But at the quantum level, particles seem to exist in a haze of possibilities until someone or something observes them. Only then do they settle into one clear outcome. This idea challenges everything we think we know about reality. How can something decide what it is only when we look at it? Does that mean reality is incomplete until we come along and pay attention? These questions may sound like riddles, but physicists have tested them over and over again in labs all around the world, and the results remain the same. Nature, at its smallest scales, simply refuses to behave in ways that make sense to our everyday minds. Many scientists have tried to explain this in different ways. Some believe that particles do not really exist as separate things, but as waves of probability. They live in a state of superposition, a cloud of all possible states at once, until the act of measurement collapses that cloud into one definite outcome. Others suggest that maybe our consciousness has something to do with it. Could it be that the very fact that we are aware, that we look and wonder and measure, brings reality into being in its final form? When you hear people talk about the simulation hypothesis, they often bring up quantum physics, because it offers these mind-bending clues that our universe might not be as solid and certain as it seems. Some researchers wonder if the quantum world's unpredictability is like the flicker of a program deciding what to render next. Just as a video game only draws what the player needs to see, perhaps the universe only decides what to be when we ask it a question. It is a haunting and beautiful thought that the fabric of reality is both stranger and more flexible than we ever imagined. Instead of being a cold clockwork machine, the universe might be more like a dream that takes shape as we watch it unfold. Maybe it is a story we write together with every glance, every question, every spark of curiosity that makes us human. So tonight, as you rest your head and feel the gentle pull of sleep, remember that at this very moment, countless tiny particles are dancing just out of sight. They move through you and around you, choosing where to be, how to be, and when to be, in ways no one fully understands. They are the tiniest storytellers, whispering that reality might be more like a shifting dream than we ever dared to believe. And in that dream, you are the observer, the curious mind that helps bring it all into focus, one sleepy breath at a time. If you could shrink down to a size so small that you could slip between atoms, you would find yourself in a place that feels more like a dream than anything we can see with our eyes. This place is called the quantum realm. Here, the usual rules of everyday life start to fade away, replaced by a world that is alive with possibilities. It is a realm where the tiniest pieces of nature do things that sound like magic, yet they are very real and have been tested over and over again by scientists who sometimes cannot believe what they see. In the quantum world, a particle is not just a particle. When we picture a particle, we might think of a tiny solid dot, like a grain of sand, so small we could never see it. But in the quantum realm, that tiny grain is not fixed in one place. It behaves more like a wave that spreads out, touching many places at once. It is as if a single particle can explore every possible path, drifting through space like ripples across a pond. One of the most remarkable things about this is that a quantum particle can exist in more than one state at the same time. This idea is called superposition. Imagine if you could be both asleep in your bed and awake at your desk at the same moment. Or imagine a light switch that is both on and off at once. In the quantum realm, particles do not choose one option until they are measured or observed. Until then, they live in a haze of possibilities, all states overlapping like a soft cloud of potential. Quantum particles can also vanish from one spot and appear in another without crossing the space in between. This is called quantum tunneling. It is as if a tiny particle finds a hidden shortcut through what should be a solid wall. In the everyday world, this would be like tossing a ball at a brick wall and watching it pass through as if the bricks were never there. Quantum tunneling is not just a fantasy. It happens inside the sun and inside the tiny electronic parts of your phone or computer. Without tunneling, many things in our modern world would not work at all. But perhaps the strangest wonder of all is the way particles can stay connected, no matter how far apart they are. This is known as quantum entanglement. When two particles become entangled, they share a link so powerful that what happens to one instantly affects the other, even if they are on opposite sides of the universe. It is like two tiny friends who can whisper secrets to each other across the stars without any wires or signals. Einstein himself called it spooky action at a distance because it seemed so impossible, and yet experiment after experiment has shown that entanglement is real. These strange behaviors make the quantum world feel alive in a way that is hard to put into words. A single particle can act like a wave, spreading out and exploring every path it could take. It can tunnel through barriers that should stop it. It can become entangled with another particle, forming an invisible bond that space and time cannot break. Each of these tricks has been proven in the lab, measured by careful scientists who still shake their heads in wonder. But why does any of this matter? Why should we care about particles that vanish, reappear, and whisper across the universe? Because they remind us that reality is not as fixed or certain as it looks from our beds and windows. They hint that under the surface of what we see, there is a hidden layer that behaves in ways that do not follow the ordinary rules. It is like living in a house that you have always known, then discovering secret doors and hidden stairways that lead to rooms you never imagined. For some scientists and philosophers, the strangeness of the quantum world opens the door to the idea that our universe might be more like a simulation than we think, if particles do not settle into one clear place until they are observed. It feels similar to a computer program that only shows you what you need to see when you look. It saves energy, it saves memory, and it makes the system more efficient. Could the universe be doing the same? Of course, there are many explanations for why the quantum world is so strange. Some believe that these mysteries are simply a sign that we have not yet found the right way to describe reality. Others believe that our minds are just not built to see the world at this tiny scale. But no matter how we explain it, the quantum realm keeps whispering that there is more to reality than meets the eye. So tonight, as you close your eyes and drift closer to sleep, imagine that you are floating through this hidden world. Picture particles that spread out like waves, tunnel through walls, and send messages across the stars. Let yourself wonder if maybe, just maybe, these tiny ghosts in the machine are hints that the story of reality is even stranger and more beautiful than we could ever imagine. And if it is all a simulation, then you are the dreamer, helping to bring it to life, one gentle breath at a time. Sometimes it takes just one simple experiment to shake the foundations of how we see the universe. The double-slit experiment is exactly that, a test so gentle in its setup and yet so wild in what it reveals that even the greatest physicists have been left wide-eyed, scratching their heads in wonder. Imagine this: you have a tiny gun that can fire one single particle at a time. That particle could be something like an electron, a piece of matter so small that billions and billions of them sit quietly inside the tip of your pencil. Now, in front of this gun, you place a wall with two narrow slits cut into it, side by side. Think of them like two tiny doorways leading to a bright screen that will catch any particles that make it through. If the world were completely predictable, you might expect each electron to travel through one slit or the other, just like marbles rolling through one of two tunnels. After firing many electrons, you would expect to see two piles or bands appear on the screen, one band behind each slit. That would make sense, wouldn't it? But the universe loves surprises. Instead of forming two neat bands, something remarkable happens. When scientists ran this test, they found that the electrons formed not two bands, but an interference pattern, a series of light and dark stripes on the screen, just like the pattern made by overlapping waves. It was as if each electron passed through both slits at once and interfered with itself, creating ripples that canceled each other out in some places and added up in others. How could this be? How can a single particle be in two places at the same time, behaving like a wave that spreads out into endless possibilities? This is where the double-slit experiment becomes more than just a laboratory trick. It shows us that at the quantum level, particles are not just tiny dots of matter. They can act like waves too. They drift through space as a haze of all possible paths until something or someone asks them to choose. But the story gets even stranger. Scientists wondered, What if we set up a detector to see which slit the electron really goes through? After all, in our everyday world, things have to pick a path. If you walk through a doorway, you choose one or the other. You cannot drift through both like a ghost. So the researchers put tiny detectors at the slits to watch each particle's journey. The moment they did that, the magic disappeared. The interference pattern vanished. The electrons stopped behaving like waves and started behaving like solid marbles again, choosing one slit or the other. The mere act of watching, of measuring, forced the particles to settle into one path. It was as if the electrons knew they were being observed, so they collapsed their wave of possibilities into a single choice. The universe changed its story the moment someone peeked behind the curtain. This simple test has been repeated countless times with electrons, photons, even large molecules made of hundreds of atoms. The results are always the same. Left alone, these tiny pieces of matter spread out like waves, exploring every possibility. Watched closely, they snap back into a single clear path. This is the observer effect, and it sits at the heart of quantum physics. What does this mean for our idea of reality? It suggests that the universe is not fully formed until it is measured or looked at. Imagine walking through a forest in a video game. The distant trees are not drawn in full detail until your character moves closer. The game engine saves energy by only showing what you need to see. Could the universe do the same? Could the quantum world be a natural version of this, revealing its secrets only when a conscious mind asks? The double-slit experiment makes us question what it means to be an observer. Are we creating reality just by looking at it? Or is there something about measurement, about the interaction between particles and our instruments, that nudges the universe to make up its mind? Some physicists think that consciousness might be the key. Others believe it is simply a quirk of the math, a reminder that our human brains struggle to grasp the quantum dance. No matter which idea you choose, this experiment stands as a reminder that reality is not always solid or certain. It flickers between possibilities like a candle in the dark, settling into one story only when we choose to look. That thought can feel unsettling, or it can feel magical. It means that the world is alive with potential, waiting quietly for you to wonder, to question, to peek through your own double-slit doorway. So tonight, as you close your eyes and drift towards sleep, imagine all those tiny electrons weaving through their slits, spreading out like waves of moonlight on water. Imagine them choosing where to be, only when someone cares enough to watch. And remember that you too are an observer in this strange, shifting world, a dreamer whose gentle curiosity brings the universe into focus, one sleepy thought at a time. If there is one idea in quantum physics that still makes even the brightest scientists pause and scratch their heads, it is the observer effect. You can picture it this way. In the quantum realm, a tiny particle does not act like a tiny speck of dust that stays in one place. It acts like a wave, spreading out, drifting through many paths, exploring all the places it could possibly go. This wave holds all the possibilities inside it. A particle might be here or over there, or maybe in both places at once. It is only when you stop and look, when you set up a detector or measure it with a careful instrument, that the wave collapses into a single clear outcome. In that moment, the particle decides where it is. It picks a path, settles down, and the haze of possibilities disappears. To many physicists, this is one of the most baffling truths they have ever faced. Imagine walking into a dark room where 100 doors lead off into the unknown. Before you flip on the light, every door is open, every path waiting. The moment you switch on the light, only one door remains. The rest fade like ghosts. The observer effect says that at the tiniest level, our universe might work in just that way. The famous double-slit experiment shows this perfectly. Without a watchful eye, particles spread out like waves and create patterns of interference, like ripples in a pond. But when you watch closely, they behave like tiny marbles, choosing one slit or the other and leaving the wave pattern behind. It is as if the particles know you are watching and snap into place to hide their wave-like nature. The universe shifts the moment you peek behind the curtain. This idea does not just show up in one experiment. It appears in countless tests run in labs all over the world. Again and again, the quantum world reminds us that it is not fixed and certain until someone pays attention. Many physicists accept this without fully understanding how it works. Some suggest that it is not human consciousness that makes the change happen, but the interaction between the measuring device and the particle. Others wonder if our awareness is somehow deeply tied to this strange behavior. They debate, they test, they write new theories, but the core puzzle remains. Why does this matter to you and me as we drift off to sleep? Because the observer effect invites us to think of reality as something alive, something that listens and responds. It means that you are not just a passive guest in the universe, sitting back while the story plays out. You are part of the story, the dreamer whose gaze helps shape what is real. Just by looking, asking, and wondering, you bring possibilities into focus. Some scientists see this as a clue that our universe might work like a giant simulation. In many video games, the world does not render in full detail until the player looks around. The distant mountains do not appear pixel by pixel until your character climbs the hill and turns to see them. This saves energy and makes the game run smoothly. Could the universe be doing something similar? Could it be that reality only renders the details you need when you need them? Maybe the quantum world is the ultimate efficiency, a cosmic program that saves its energy until you watch. Of course, not everyone agrees. There are other explanations. Some say the observer effect is simply a reflection of our limited tools. The act of measuring is messy. When we poke and prod tiny particles, we disturb them. We cannot observe them without leaving fingerprints behind. Maybe that is all there is to it, an echo of our clumsy hands reaching into a world too small to hold still. Yet, even this idea does not take away the wonder. It means the universe is full of secrets, waiting to be revealed only when we dare to look. It is a reminder that curiosity is one of our greatest gifts. The observer effect tells us that our questions matter. They have the power to shape the answers, one tiny measurement at a time. So tonight, as you close your eyes and drift into dreams, imagine those tiny particles swirling in their haze of possibilities. Picture them settling into place the moment someone watches, like fireflies gathering into a gentle pattern. You are the observer. You are the dreamer. You are the one whose quiet gaze helps bring the universe into focus. And perhaps, just perhaps, that is the most magical part of all. Now, drift into this idea for a moment. Let it roll around in your mind like a marble on a quiet floor. Imagine you are the player inside a beautiful video game. Maybe it is a peaceful game set in the mountains, or a fantasy world with rivers, forests, and starlit skies. Wherever your character goes, the world springs into life. The grass appears underfoot, the trees sway in the wind, the birds take flight from branches that were not there until you looked up. But here is the secret. None of it truly exists in full detail until you need it. In the world of games, this is called rendering. A video game is built from lines of code that tell the computer what to create and when. It is not practical for the game to create every blade of grass or every rock on the other side of the mountain all at once. Instead, it waits, it saves its energy, it draws only what you can see. If your character stands on a hilltop and looks west, the east side remains blurry, half finished, just an idea waiting for you to turn around. Now think about this. Could our universe do something similar? In the everyday world, you trust that everything is always there, whether you are looking or not. The chair behind you stays where it is, even when you are asleep. The tree down the street does not vanish when you walk away. But when we look closer, much closer, at the tiny pieces that make up everything, the quantum world begins to whisper something stranger. Remember how, in the quantum realm, particles drift in a haze of all possible places they could be? They act like waves, spreading out through every path until you come along with your measuring tool or simply your observation and ask, "Where are you?" And suddenly the wave of possibilities collapses. The particle chooses. It is as if, until you needed the answer, the particle held on to every possible version of itself. Only your question brought one version into focus. This is where the idea of a cosmic code becomes so fascinating. Some scientists and philosophers wonder, what if the universe works like an unimaginably vast video game? What if there is a hidden layer of code running quietly beneath our feet, deciding what to render based on what we need to see? It does not mean that the world around you is fake. Just like a game that feels real in your hands, the trees and stars are very much there when you see them. But perhaps, at the deepest level, they come into being fully only when your eyes or your instruments demand it. In this idea, observation is more than just looking. It is an interaction, a handshake between your mind and the fabric of reality. It is the moment when the program says, "Ah, you are here. Let me show you what is possible." Some thinkers say this explains why the universe can feel so efficient. If everything were fixed forever, the energy required would be impossible to measure. But if the universe creates itself on the fly, only rendering what it needs to, then it becomes a masterpiece of cosmic design, like a video game that never crashes because it only shows you what you truly need. Does this mean that we live inside a giant computer? Not exactly. It means that nature might behave like information, following rules that feel like code. Quantum particles flicker between states like switches in a circuit. They communicate across space as if following hidden instructions. The more we study these patterns, the more they look like algorithms, sets of instructions that tell the universe how to grow stars, how to spin galaxies, how to create you. Some scientists see this idea as hopeful. It means that the universe is not cold and indifferent. It is alive with potential. It is flexible, shifting, capable of surprise. Every time you open your eyes, ask a question, or wonder what might be, you invite reality to unfold in new ways. In this view, you are not just a passenger in a machine. You are a co-creator, a player who helps render the world, pixel by pixel, idea by idea. Of course, not everyone agrees. Some physicists say this is just a poetic way of describing quantum measurement. They remind us that the math works whether we think of it as code or not. But even they cannot deny the wonder. The fact that the universe might need you to look, to measure, to care, that alone makes this world feel a little more magical. So tonight, as you settle deeper under your blanket, think of yourself as a curious traveler in a vast cosmic simulation. Imagine the particles dancing just out of sight, waiting to be seen. Picture the hidden code that weaves trees from sunlight, starlight, and possibility. And remember, when you open your eyes, you are the player and the observer. You help reality choose which path to take. One question at a time, one dream at a time, one sleepy breath at a time. Now that you have drifted through the quantum world, where particles act like waves, where observation shapes what is real, and where nature seems to flicker in and out of existence like code, you might feel ready to meet one of the most fascinating and mind-bending ideas ever proposed about the nature of reality. It is called the Simulation Hypothesis. At its heart, the Simulation Hypothesis asks a simple but unsettling question. What if our universe is not the original reality, but a carefully crafted copy, a digital world so perfect that the people inside it, people like you and me, have no way of knowing it is not the first version? This idea did not just come from science fiction writers or video game designers. It was given serious shape by a real philosopher named Nick Bostrom, who teaches at Oxford University. In the early 2000s, Nick Bostrom wrote a paper that made scientists, philosophers, and curious dreamers sit up straight in their chairs. He argued that if any civilization, even just one, becomes advanced enough to create what he called ancestor simulations, then the odds that we are living in one of those simulations might be higher than we think. But what are ancestor simulations? Picture a future civilization so advanced that they have unimaginable computing power. These future people, or beings, or machines could decide to run simulations of their own history. Maybe they want to study how their ancestors lived. Maybe they want to see how certain events could have turned out differently. Or maybe they just want to play out endless stories of how life could unfold. Inside those simulations, every detail could be rendered so perfectly that the people inside would feel real feelings, dream real dreams, and believe they are living in the base reality, the original universe that started it all. Those simulated minds would not be fake. They would be conscious, thinking beings. And here is the part that gives this idea its strange power. If even one advanced civilization creates countless ancestor simulations, then the number of simulated minds would quickly outnumber the original biological ones. Think of it like a branching tree. You start with one real civilization. That civilization develops the technology to create thousands or millions of simulations. Each of those simulations could create their own versions, and on it goes. With so many branches, it would be far more likely to find yourself in one of the countless copies than in the single original reality. In other words, the math starts to lean toward the idea that we are probably living inside one of those branches, rather than sitting safely at the root. Bostrom did not say this is definitely true. In fact, he laid out 3 possible paths, which we will explore more deeply later. But his argument opened the door for scientists, philosophers, and even ordinary people to wonder, could we really be living in a simulation? And once you open that door, it is hard to shut it again. When you look around your room tonight, your soft pillow, your warm blanket, the way the shadows shift on your wall, everything feels real because it is real to you. If you stub your toe on the bed frame, you feel pain. If you taste your favorite food, you feel joy. None of that goes away if you learn that everything is built on some hidden layer of code. In fact, it might make it even more precious. If you are inside a story, it means every thought and feeling you have is part of something bigger, a program that needs you in order to keep running. Some people find the simulation hypothesis comforting. They imagine that if there is a creator, a programmer, so to speak, then maybe there is a plan. Maybe we are cared for by something or someone watching from beyond the screen. Others find it unsettling. They worry about the idea of being controlled, or that everything we do is just data being processed by an invisible machine. And yet, when you look at how our own technology has grown, it is not so hard to imagine. Think about how far we have come in just a few decades. Once, computers were the size of rooms and could only solve simple problems. Now we hold tiny supercomputers in our pockets. We create virtual worlds where our characters explore forests, build cities, and fall in love. Every year, these simulations become more realistic. What will they look like in 1,000 years or 1,000,000? Nick Bostrom's thought experiment is not meant to scare you. It is meant to make you curious, to remind you that the world may be far stranger and more magical than we know. The simulation hypothesis invites us to question what we take for granted. It whispers that reality might be layers upon layers of stories, each one woven into the next. And it reminds us that, even if we are living in a simulation, the sunsets still glow, the laughter still echoes, and the dreams we dream still matter. So tonight, as you drift closer to sleep, hold this idea lightly in your mind. What if you are part of a cosmic story, running line by line in a perfect hidden code? What if every breath you take is a line in a poem written by something bigger than any of us could ever imagine? And what if, by simply wondering about it, you become part of the story that will be told again and again in worlds both real and imagined? For as long as there are dreamers who dare to ask, what if? So far, we have drifted through quantum weirdness, particles that change when you look, and the idea that our universe might act like a giant, perfectly coded video game. We have met the simulation hypothesis and the philosopher Nick Bostrom, who asked, what if advanced civilizations could run ancestor simulations so real that the minds inside them feel alive? But Bostrom's idea does not just stop at maybe we live in a simulation. He laid out something he called a trilemma, 3 big possibilities that, when you think about them, make you realize just how strange and surprising the question really is. Let's explore each one together. Imagine each as a door in a long hallway. You can peek through each door and wonder which one we are standing behind right now. The first possibility is this: maybe no civilization ever survives long enough to reach the point where they can create ancestor simulations. This means that every intelligent species in the universe, not just humans, but any being that learns to build computers and launch rockets, might always reach a point where something stops them. Perhaps they destroy themselves with their own technology. Perhaps they use up their planet's resources too quickly and cannot find a way to live among the stars. Maybe they meet disasters that wipe them out before they can even think about creating entire digital worlds. If this first door is true, then we humans might never make it to that future either. It is a sobering thought, and it reminds us how fragile life can be. But it is also a gentle nudge that perhaps we should take care of our world and each other, because our choices now may shape whether we ever become that advanced civilization. The second possibility is a little different. Maybe civilizations do survive and become incredibly advanced. They could build computers more powerful than anything we can imagine, and they might have the skill to create realistic, conscious minds inside perfect digital worlds, but they choose not to. Perhaps they decide that running ancestor simulations is wrong, that it is unethical to create countless beings who feel real emotions, joy and pain, just for study or entertainment. Or maybe they simply lose interest. They might have other mysteries to chase, other ways to use their energy and knowledge. This second door feels hopeful in a way. It suggests that intelligent beings, once they become wise enough, might also become more compassionate and careful with what they create. They might look back on their own ancestors, people like us, with respect and not want to recreate our struggles, just to watch them unfold again and again. If this door is true, it would mean that you and I are not living in a simulation, because no one ever built one. Then there is the third possibility, the one that makes the simulation hypothesis so famous. This is the door that says, if civilizations do survive and they do run ancestor simulations, then they might run millions or even billions of them. Each one would be filled with minds like ours, minds that feel and think and wonder. If there are countless simulated worlds and only one base reality, then the odds that you are in the original reality become very, very small. The math tips in favor of us living in a simulation, not the original version of life. Imagine a library with billions of books. One of those books is the original story. All the other books are perfect copies, so perfect that each character in each book believes they are living the first and only version. If you open a random book and meet the characters inside, chances are you are meeting characters from one of the copies, not the original. This is how Bostrom's trilemma works. If the third door is true, it means that our world, our forests, oceans, and even our deepest memories might all exist inside a vast digital story. Of course, we cannot peek behind these doors to know which one is ours. That is what makes this trilemma so powerful and so haunting. It invites us to ask big questions about what it means to be real. Are we the first? Are we one of many? Or are we the kind of beings who never make it that far? No matter which door you lean toward, the trilemma reminds us that life is precious. If we are real, then this is our one shot to live and dream and love. If we are a simulation, then this story still matters because it is the only one we have. And if we never reach the point of creating simulations, maybe that is a quiet sign that we should take better care of the only world we know. So tonight, as you drift closer to sleep, think of these 3 doors and which one you hope lies ahead. The future, whether it is written in stardust or in code, is still being shaped by our choices now. And maybe, just maybe, that is the greatest mystery and the greatest gift of all. Sometimes, the closer you look at something, the more solid it appears. A wooden chair seems sturdy. You can sit on it and trust it will hold you. But if you could shrink yourself down small enough to drift inside the wood, you would find something surprising. The solid chair is mostly empty space. It is made of atoms, tiny clusters of particles, spinning and dancing in a great, invisible ocean. If you go even deeper, you reach the quantum realm, where these particles begin to look less like tiny marbles of matter and more like ripples, vibrations, and waves of pure possibility. This idea has made many scientists wonder if what we call stuff is really made of stuff at all. Maybe, at the deepest level, it is made of information, not the kind of information you read in a book or see on your phone, but the raw bits that make up the rules of everything, a kind of cosmic language hidden beneath the particles and waves. In the world of quantum physics, there is a special word for these tiny pieces of information: qubits. The word qubit stands for quantum bit. In regular computers, the smallest unit of information is a bit. A bit is either a 1 or a 0. Each bit is like a tiny switch that can be on or off. When you add billions of these bits together, you can write words, store pictures, and build virtual worlds in a video game. But qubits are different. They are like bits that belong to the quantum world. A qubit does not have to choose between 1 and 0. It can be 1, 0, or both at the same time, thanks to something called superposition. This is the same weirdness we saw with particles that spread out like waves and explore all paths at once. When you use qubits in quantum computers, they can handle many possibilities at once, solving problems that would take ordinary computers thousands or even millions of years. Some scientists believe the whole universe might work this way. Maybe particles are not tiny bits of matter, but tiny bits of quantum information. The universe could be like an enormous quantum computer, where every star, planet, and person is a pattern written in qubits. Each qubit holds instructions for how the universe should behave, spin, and grow. If this sounds a bit like the simulation hypothesis, you are not wrong. The idea that reality could be built from information ties neatly into the thought that we might be living in a digital world. After all, if you run a simulation on a computer, you do not have to build tiny marbles or grains of sand inside your machine. You only need to write code that tells the machine how each piece should behave. In the same way, if our universe runs on qubits, it might mean that what we see as real is really a flowing river of quantum information, creating the illusion of solid things. This does not make the world feel any less magical. In fact, it can make it feel more alive. Information is flexible. It can move, shift, and change in ways that lumps of hard matter cannot. If the universe is built from qubits, it means the rules of reality are like a living conversation. Each qubit interacts with the others, weaving the fabric of the cosmos moment by moment. It means that the world is not frozen and fixed, but endlessly unfolding. Some thinkers believe that this idea could even explain why quantum particles behave so strangely. Why do they spread out like waves? Why do they only pick a clear path when you watch? Maybe it is because the information that shapes them holds many possible outcomes. Observation acts like a question. What are you right now? And the universe, through its quantum code, chooses an answer. Quantum bits are not just an idea for physicists. They are becoming real tools in the world we live in. Scientists are already building quantum computers that run on qubits. These machines can tackle problems that regular computers could never solve. They might help us design better medicines, unlock secrets of space, or even test whether reality itself has a hidden code. Whether or not we ever find that ultimate code, the idea of the universe as information reminds us of something beautiful. It means that the universe is not cold and lifeless. It is a story told in the language of quantum bits, an endless flow of ones, zeros, and all the shimmering states in between. It is a reminder that when you look out at the night sky, every star, every drifting particle, and even every thought in your mind is part of a living pattern of information, woven together like a cosmic poem. So tonight, as you drift off under your blanket of dreams, imagine yourself as part of this river of quantum bits. Picture the stars above as glowing nodes in an infinite web of information. Feel the gentle hum of the universe as it runs its code, creating you, your memories, and every possibility yet to come. And remember, you are more than just matter. You are part of a cosmic message, one that is still being written, line by line, one sleepy breath at a time. Look closer, closer than you have ever looked before, and you will find that reality itself might have a limit. It is not always easy to imagine something so small that our eyes can never see it, our hands can never touch it, and even our most powerful microscopes cannot fully reveal it. But if you keep peering deeper and deeper into the fabric of the universe, you eventually come to something called the Planck length. The Planck length is named after Max Planck, a physicist whose work helped give birth to quantum theory more than a century ago. He showed that the universe, at its tiniest scales, might not be endlessly smooth and continuous. Instead, it could be grainy, like an invisible fabric woven from the smallest possible threads. The Planck length is the measurement of those threads, the shortest possible distance that still has meaning. How small is the Planck length? It is so tiny that if you were to blow up a single atom to the size of our entire observable universe, the Planck length would be about the size of a tree in that universe. It is beyond small. It is so mind-bogglingly tiny that it almost does not feel real. And yet for scientists and dreamers alike, it holds a deep meaning. It hints that there is a limit to how finely we can slice up space. To understand this better, think of your computer or phone screen. Up close, the images look smooth. A sunset, a face, a tree swaying in the breeze. But if you press your nose right up to the glass, you can see tiny squares of light. These are pixels. Each pixel is like a tiny building block that helps create the image you see. No matter how powerful your eyes are, you cannot see anything smaller than a pixel on that screen, because that is the screen's resolution limit. Now imagine the universe itself works like this. The Planck length would be nature's ultimate pixel size. It would be the smallest possible unit that makes up space, a single dot in a cosmic grid. If this is true, it means that space is not infinitely smooth like a calm ocean. Instead, it is a pattern of tiny vibrating pixels that give shape to everything you see, from the tallest mountains to the smallest grain of sand. This idea fascinates physicists because it means that reality might be digital at its deepest level. The world you walk through, the bed you lie on, the pillow you sink your head into, all might be built from these quantum pixels that join together to create the illusion of solid matter. It is like a cosmic video game where everything is rendered from a limited number of dots. One reason the Planck length matters is because it helps scientists search for clues that our universe could have a resolution limit. They look at the way light travels across vast distances in space. If the universe were truly pixelated at the smallest scales, then light might scatter or blur in tiny ways that we can detect with our most sensitive telescopes. Some researchers examine the cosmic microwave background, the faint glow left over from the birth of the universe, to see if it holds hints of this hidden grid. If this grid exists, it could connect to the idea of the simulation hypothesis. A simulation would not need infinite detail. It would have a limit to how finely it could render space, just like any video game or computer model. The Planck length would be the ultimate proof that the universe has a built-in resolution, a sign that it runs on a code that keeps it efficient and elegant. Of course, not every scientist agrees. Some say the Planck length is just a mathematical limit that helps make sense of equations. It may not mean that space is truly pixelated. Maybe the universe is still smooth and continuous beyond what we can see. But the idea itself sparks a sense of wonder. It reminds us that there might be hidden patterns we have not yet discovered, an invisible grid under our feet and above our heads, holding the stars in place. For dreamers, the Planck length is a symbol of how tiny things can hold giant mysteries. Something so small that it makes atoms look enormous could shape the way reality itself unfolds. And if our universe really is pixelated, it means that the world is both real and built from something we cannot touch, tiny dots of pure information that dance together to create all that we see. So tonight, as you drift closer to sleep, imagine yourself shrinking smaller and smaller, down past cells and molecules, past atoms and electrons, all the way down to the Planck length. Picture yourself standing on nature's ultimate grid, a landscape of quantum pixels humming with potential. Let it remind you that the world is full of hidden patterns waiting to be seen, whether you find them in the stars above or in the tiniest pieces of space beneath your pillow. You are part of this beautiful pixelated story, and that is a dream worth drifting into. By now, you have wandered through some of the strangest corners of the quantum world, particles that act like waves, things that exist in many places at once, and the observer effect that makes reality settle down only when you watch. These odd behaviors can feel like riddles with no easy answers. But what if there is a single idea that ties them all together? Some scientists and philosophers believe the simulation hypothesis might do just that. Think of it this way: if our universe is a kind of digital world, like a video game or a giant program running on a cosmic computer, then maybe the weirdness of quantum physics is not so weird after all. Maybe it is exactly how a clever simulation would work. Take quantum entanglement, for example. This is the spooky connection between particles that Albert Einstein called spooky action at a distance. When two particles become entangled, what happens to one instantly affects the other, even if they are separated by vast distances. It is as if they share a secret channel no one else can see. In a universe made only of physical matter, this connection seems impossible, but in a digital world, it is easier to understand. Imagine two characters in a game standing far apart. To the characters, it looks like they are on opposite sides of a huge map, but behind the scenes, they are connected by the same lines of code. The program can change one and instantly update the other, no matter how far apart they appear to be. The distance is just part of the illusion, and some scientists wonder if entanglement is a sign that our universe might work like this too, with hidden connections running underneath everything, like code linking the pieces together in perfect sync. Now think about superposition. This is the idea that a particle can exist in many states at once, here and there, spinning this way and that way, until it is measured. It sounds impossible, but experiments have shown that it really happens. For a long time, physicists struggled to make sense of it, but if you look at it through the lens of a simulation, it begins to feel familiar. Picture a video game again. When you play an open-world game, not every tree, stone, or animal is fully rendered all the time. It would take too much memory and slow everything down. Instead, the game waits until you need something, then it fills in the details. Some people say superposition might work in the same way. A particle drifts in a haze of possibilities, like a character in a game that has not loaded yet. When you observe it, the universe renders one version, just like the game draws the mountains when you turn your head. Even quantum randomness, which once seemed like pure chaos, fits this idea in an interesting way. In quantum physics, there are rules that govern how particles behave, but there is also unpredictability. A particle's exact path is not always certain. Some scientists call this randomness a feature, not a flaw. If the universe is a simulation, tiny bits of randomness might keep the system flexible and alive. In games and computer models, randomness adds variety, so things do not look too predictable or artificial. It keeps the world fresh and surprising. Maybe the same is true for us. Maybe the little unpredictabilities woven into the quantum world are the universe's way of adding texture to the story. Of course, not every scientist agrees. Many still see quantum weirdness as simply a reflection of how nature works. No hidden code, no cosmic computer. They believe we just have more to learn about how particles and forces interact. But even they admit that the way quantum puzzles line up with the logic of a simulation is fascinating. It opens the door to new ways of testing, new questions to ask, and a fresh sense of wonder for what reality might truly be. If this is true, if the universe is like a program, then you are not just a passive character drifting through lines of code. You are part of a living story. Your thoughts, questions, and curiosity help shape the world you see. When you wonder about entanglement, you are tugging gently on the invisible strings that hold particles together. When you dream about superposition, you are letting your mind drift through every possible path. And when you accept that a little randomness will always be there, you are embracing the idea that this world, whether physical or digital, is alive with surprises. So tonight, as you close your eyes and drift toward sleep, imagine the tiny particles around you, flickering in and out like bits of code in a cosmic game. Picture them sending messages across space, waiting to be seen, and choosing their paths just for you. Maybe the greatest wonder is not whether we live in a simulation, but that we get to ask the question at all, that we get to look behind the curtain and find the world shimmering like pixels on a screen. And maybe, just maybe, every dream you have tonight is another gentle line of code written by the universe just for you. And then there's the holographic principle, a mind-bending idea that feels like something out of a sci-fi story, yet real physicists study it with great seriousness. The holographic principle says that our entire three-dimensional world might be a projection from a two-dimensional surface. Imagine that for a moment, a universe that seems deep and vast, but that could actually be like an enormous cosmic hologram. To understand this, think about a regular hologram you might have seen before. A hologram is a special kind of image that can appear three-dimensional when you look at it from different angles. Maybe you have seen one on a credit card or a sticker that changes shape when you tilt it. Even though the picture looks like it has depth, as if you could reach inside it, it is really flat. The depth is an illusion created by the way light interacts with the image. Now imagine that idea on a scale too big for our minds to fully picture. What if everything around you, the chair you were sitting on, the book on your shelf, the moon outside your window, is really a three-dimensional illusion projected from a two-dimensional boundary that you cannot see? This is what some physicists believe the holographic principle suggests. This idea first grew out of trying to understand black holes, those mysterious places in space where gravity is so strong that not even light can escape. When scientists studied black holes, they discovered something puzzling. According to the math, all the information about what falls into a black hole seems to be stored on its surface, not inside its deep, dark center. It is like every detail is flattened and etched onto the skin of the black hole. This strange result made physicists wonder, what if this is not just true for black holes? What if the whole universe works like this? Maybe all the information that makes up you, me, the Earth, and the stars is stored on a vast cosmic surface far away at the edges of our universe. The world you touch and see would then be like a 3D movie projected from that distant surface. Some call this the ultimate trick of nature, reality appearing solid and deep, when at its core it might be a complex, beautiful pattern on a cosmic screen. It means that the deepest layer of our reality is not the 3D space we move through every day, but the 2D surface that holds all the information needed to create the illusion. At first, this sounds so strange that it is easy to dismiss, but the math behind it is solid enough that it has become one of the most studied ideas in modern physics. Some scientists believe the holographic principle could help explain why quantum mechanics, the science of tiny particles, and general relativity, the science of big things like planets and galaxies, do not always agree. If the universe is a hologram, it could help stitch these two ideas together like a neat thread that weaves the big and the small into one tapestry. The holographic principle also feels like it fits naturally with the idea of a coded universe. Think about a computer game again. The game's world is three-dimensional to you, the player, but on your computer's hard drive, it is all just information. Lines of code stored in 2 dimensions. The depth, the mountains, the rivers, they only appear when the game runs the code and projects it onto your screen. The same might be true for us. The code could live on that 2D boundary, while the universe we know springs to life as a rich 3-dimensional experience. Of course, there are still many questions. If our universe really is a cosmic hologram, who or what writes the code? Is it a natural process, an echo of a deeper law of physics, or something beyond our understanding? For now, No one knows for sure. Scientists are looking for ways to test the idea by searching for tiny patterns in the background radiation left over from the birth of the universe, or by studying how particles behave in extreme conditions. If they find signs that the universe has a resolution limit or certain repeating patterns, it could be a clue that the holographic principle is more than just an interesting theory. But whether or not we ever prove it, the holographic principle invites us to see reality with fresh eyes. It reminds us that things are not always as they appear. It whispers that there might be hidden layers behind the world we see, patterns that hold the secrets of existence in places we have yet to look. So tonight, as you close your eyes, imagine the universe as a shimmering cosmic hologram. Picture stars and galaxies projected from a distant surface you can only sense in your dreams. And remember that even if reality is a kind of illusion, your place in it is real. You are the dreamer who brings the pattern to life, a living part of this grand, beautiful projection that stretches across the endless sky. By now, you have drifted through some of the strangest corners of the universe. You have peeked into the quantum realm, where particles behave like waves and change when you look. You have imagined reality as information, built from qubits or tiny Planck pixels that might be nature's ultimate grid. And you have tiptoed along the edge of the holographic principle, the idea that our deep, rich, three-dimensional world could be a projection from a two-dimensional surface. If all this is true, if our universe really does work like a cosmic simulation, it raises one more question that makes even the sleepiest mind sit up and wonder, could we ever detect it? Could we find evidence that we are living in a kind of digital dream, woven together by a hidden cosmic code? It is an idea that tickles the imagination. After all, in the world of computers, glitches sometimes happen. A line of code goes wrong, and you see a flicker on your screen. A character in a video game might get stuck walking in place, repeating the same action over and over. Sometimes the background does not load properly, and you catch a glimpse of what the world looks like without its final layer of paint. So it is only natural to wonder if our reality is running on some unimaginable supercomputer. Could there be glitches in the cosmic code? Little signs that something behind the curtain is not quite perfect. Some scientists have actually tried to look for these clues. They have asked whether we might find repeating patterns in places where we would not expect them, like tiny echoes left behind by whoever or whatever built the program. One idea is to look for patterns in cosmic rays, the high-energy particles that zip through space and sometimes collide with Earth. These particles travel for billions of years, crossing vast distances. If the universe has a resolution limit, like the pixels on your screen, then maybe the highest energy cosmic rays would reveal signs of that limit. They might scatter or lose energy in unusual ways, leaving behind a fingerprint of the hidden grid. Others search the cosmic microwave background, the faint glow left over from the birth of the universe. This ancient light is like a baby picture of the cosmos, a frozen snapshot from when the universe was just a few 100,000 years old. Some scientists hope that by studying this glow in incredible detail, they might find repeating patterns or irregularities that could hint at a coded structure beneath it all. There are also experiments closer to home. In quantum physics, researchers test whether particles really do snap into place when observed, or whether there might be a hidden layer of instructions that controls this process. Could it be that entangled particles or superposition are just signs of a clever system that only updates what it needs to show? If so, what would happen if we pushed this system to its limit? Would it break or reveal a glitch? So far, no one has found a smoking gun, no clear sign that we are living in a simulation. The cosmic rays and microwave background continue to behave mostly as expected. Quantum particles remain mysterious but consistent. Still, the search itself is worth something. It reminds us that curiosity is powerful. Just by asking, could we find the cosmic code, we are already pushing the limits of what we know. And maybe that is the point. Imagine if a civilization advanced enough to build a simulation, also wanted it to feel real. They would make sure the code is tidy, the glitches rare, the patterns hidden deep within the fabric of reality. Some thinkers say that if we ever did find obvious glitches, sudden unexplained breaks in the laws of physics, it would suggest our simulation is not very good. But our universe is elegant and robust, full of surprises, yet always consistent enough to grow galaxies, nurture life, and let us ask these big questions. Others wonder whether we might even be designed to find clues someday, like cosmic Easter eggs left behind by our creators, little messages that say you are not alone, there is more to this story. Or maybe the real clues are not glitches at all, but the very strangeness of quantum mechanics. The observer effect and the holographic principle hints that reality is not as solid or simple as it seems. So tonight, as you settle into your pillow and listen to your own quiet thoughts, imagine that you are part of this search for the cosmic code. Picture physicists staring into space, studying patterns in starlight, listening for echoes of a hidden grid. Maybe they will never find a single glitch or repeating pattern that proves we are simulated, but maybe, just maybe, the greatest clue is the question itself. The fact that we can wonder whether our world is written in code, that we can dream of finding the key that unlocks the biggest secret of all. And if we are living in a simulation, remember this: your dreams, your love, your laughter, and your gentle curiosity are part of what makes the code come alive. You are the spark that turns ones and zeros into stories, the observer who brings the pixels into focus. And that is something no glitch can ever erase. If the idea of our universe being pixelated feels too strange to believe, you are not alone. Many people wonder how something so vast and smooth, like the endless stretch of space, the swirl of galaxies, the gentle curve of our Earth, could have a hidden limit to its resolution, like the tiny squares of light on your phone screen. But in 2012, a few curious researchers asked, if this hidden pixel grid exists, how might we find it? Their answer was unexpected and beautiful. They turned their eyes not just to the stars, but to something much smaller and faster: high-energy cosmic rays. Cosmic rays are tiny travelers from the far reaches of the universe. They are particles, mostly protons, that race through space at speeds close to the speed of light. Some come from our sun, but the most energetic ones come from powerful cosmic events, exploding stars, black holes feeding on matter, and other dramatic happenings we can hardly imagine. When these rays finally reach Earth, they crash into our atmosphere and break apart, creating showers of smaller particles that scientists can detect. Now, picture this: a cosmic ray has journeyed millions or even billions of light years across the universe to reach us. Along the way, it has crossed the hidden fabric of reality, that mysterious grid we talked about in the last chapter, made of Planck-length pixels. If this grid truly exists, then there might be a limit to how much energy a cosmic ray can have while still traveling smoothly through space. In 2012, some physicists suggested that extremely high-energy cosmic rays could bump up against this hidden resolution limit. It is a bit like running your finger across a very high-resolution photo. Most of the time, the surface feels smooth, but if you zoom in far enough, you begin to notice tiny dots, the pixels. For a cosmic ray, traveling across the universe would be like dragging your finger across the ultimate cosmic photo. If the ray is energetic enough, it might feel those hidden pixels and scatter or lose energy in a way that reveals the underlying grid. This idea is sometimes called the cosmic ray cutoff. If the universe is truly pixelated at the Planck length, then there might be an upper limit to how much energy a cosmic ray can carry. Any ray with more energy than that would run into the grid, scattering like a ball bouncing off a net. This would create a cutoff point, a clear sign that there is a resolution limit to reality. Scientists use huge detectors on Earth to watch for these cosmic rays. Some of these detectors are spread out over wide areas of land, waiting for tiny showers of particles that fall like invisible rain from space. Every time they capture a high-energy ray, they measure its energy and direction. They are looking for patterns, a sudden drop-off in how many rays reach a certain energy level, a point where the smooth pattern breaks. So far, the results are still a puzzle. Some experiments have hinted at small signs that a cutoff might exist, but nothing has been confirmed beyond doubt. Cosmic rays are hard to study because they come from so many places and travel so far. Along the way, they can lose energy when they bump into light from distant stars or the cosmic microwave background, that faint glow left over from the birth of the universe. Sorting out which effects come from ordinary physics and which might come from a hidden grid is a delicate task that takes patience and time. Still, the idea that these tiny messengers from space could carry clues about the deepest nature of reality is magical in itself. Cosmic rays are like postcards sent across the vastness of the cosmos. Each one carries a message, not written in ink but etched in energy and motion. They tell the story of ancient stars that exploded long before our planet was born. They whisper about black holes and swirling galaxies. And maybe, just maybe, they hold secrets about the very structure of space itself. The cosmic ray cutoff idea connects beautifully with the bigger question of the simulation hypothesis. If our universe has a resolution limit, it might be a sign that space is not smooth and infinite, but built from tiny building blocks like the pixels on a screen. And if that is true, it could hint that reality runs on code, a hidden layer of instructions that tells the universe how to grow stars, spin planets, and shape your every dream. So tonight, as you drift into sleep, imagine these tiny cosmic travelers zipping through the darkness, crossing oceans of time to reach your pillow. Picture them tapping gently on the edges of the universe's hidden grid, like curious explorers asking, "What lies beneath?" And remember, whether or not we find that cutoff, the simple fact that we can wonder about it, that we can listen to these cosmic whispers, is a sign that the universe, whether pixelated or not, is alive with questions waiting to be dreamed. By now, you have drifted through ideas that feel as soft and strange as a dream. We have imagined particles that flicker in and out of place, waves of possibilities that collapse the moment you look, and hidden grids that might hold the universe together like the tiniest woven fabric. Some dreamers hope that if we really do live in a simulation, we might find a glitch, a crack in the code, a tiny error message left behind, like a cosmic clue that says, yes, this is all running on something bigger than you know. But have we found any? Has anyone ever seen something that clearly proves the universe is not what it seems? So far, the honest answer is no, at least not in any way that most scientists would call proof. There is no smoking gun glitch that everyone agrees is real. The stars still shine on schedule. The laws of physics keep their promises, from the smallest particles to the largest galaxies. Gravity pulls, light travels, and life goes on. There are no particles popping out of place like broken pixels on a screen. No lines of hidden code scrolling behind the clouds when you look up. Reality, for the most part, behaves beautifully and consistently. Some people find that comforting. They like the idea that the world follows rules we can trust, that the sky will not suddenly flicker or vanish. Others feel disappointed. They wish for a sign, some playful hint that we are living inside a cosmic story, a secret handshake from the programmers or the universe itself. Yet, even without a clear glitch, the door to wonder stays open. In quantum physics, uncertainty and randomness are not mistakes. They are part of how the world works. Tiny particles make choices we cannot fully predict. Even when we know all the conditions, we cannot say exactly where an electron will be or which path a photon will take. It is not that our tools are too weak or our minds too slow. The randomness is built in. It is part of the universe's design. Some thinkers wonder if this randomness is like the noise you hear in an old radio, a sign of how the code works behind the scenes. In computer simulations, randomness is often added on purpose. It keeps things from looking too stiff and repetitive. Imagine a forest in a video game. If every tree were exactly the same, you would notice right away that it is fake. Randomness makes each branch bend a little differently, each leaf flutter in its own tiny way. It adds life to the illusion. Could quantum randomness be the same? Maybe the universe uses it to make sure that reality never feels too predictable. Maybe it is the programmer's way of keeping the story fresh, of adding texture to the dream we live in. If so, the glitch is not a broken thing. It is a feature, a reminder that our world, even if it runs on code, is full of surprises. There are also moments in our everyday lives when we think we see a glitch. People tell stories about coincidences, so strange they feel like reality hiccuped for a moment. Déjà vu, that eerie feeling that you have lived a moment before, is one example, or the way your mind sometimes fills in details you swear are real, only to find out they never happened. These little mysteries are fun to wonder about, but scientists say they are usually tricks of memory, not cosmic error messages. Our brains are wonderful storytellers. They connect dots that sometimes were never meant to connect. Still, the hunt for glitches is not over. Some researchers keep searching for signs in the deepest parts of physics, in cosmic rays, background radiation, or the edges of black holes. Others look for patterns that repeat where they should not, or tiny shifts in how particles interact. They run experiments so delicate, they must shield them from the noise of passing cars and even the vibration of footsteps. And who knows, maybe one day someone will spot something that does not fit, a true crack in the cosmic wall, a flicker in the universal program. But until then, the greatest glitch might be the fact that we can ask these questions at all, that you and I, made of particles and waves, can lie back under the stars and wonder if those stars are real or part of a story written in a language we do not yet understand. So tonight, as you drift off, think of the universe holding its secrets close. Think of quantum randomness, not as a mistake, but as a gentle invitation, a whisper that says, keep looking, keep dreaming, there is more to see. And remember, whether we find a glitch tomorrow or never at all, the very act of searching makes this world, real or simulated, shine with mystery and possibility. Of all the mysteries that quantum physics offers us, few feel as ghostly and strange as quantum entanglement. Even Albert Einstein, one of the greatest scientific minds the world has ever known, could not help but raise his eyebrows at this peculiar connection. He famously called it spooky action at a distance, and to this day, physicists and dreamers alike still feel a chill of wonder when they think about how it works. So, what exactly is quantum entanglement? Imagine you have two tiny particles, perhaps electrons or photons, and you prepare them in a special way so they become entangled. This means they share a bond so deep that no matter how far apart they drift, they remain linked in a secret conversation that seems to defy the laws of ordinary physics. If you change something about one particle, like the direction it spins, the other particle knows instantly and changes too. It does not matter if they are side by side in a lab or on opposite sides of the galaxy. The connection appears to happen with no delay, faster than light could ever travel from one to the other. It is as if the universe bends its own rules to keep them in sync. This puzzled Einstein deeply because it seemed to break the speed limit of the universe, the cosmic law that says nothing can travel faster than light. For him, the idea of instant influence over vast distances sounded too magical to be real. He thought there must be hidden variables, secret instructions carried by the particles from the start that explain this strange dance. But decades of experiments have shown that entanglement is real and cannot be explained away so easily. The particles really do act as if they are connected by an invisible thread that distance cannot cut. So where does the simulation hypothesis fit in? Some dreamers and scientists believe that quantum entanglement might make more sense if you think of the universe as a kind of program. In a computer game, two characters can be on opposite sides of a huge digital world. To them, it feels like they are far apart, but behind the scenes, the game's code links them instantly. The computer does not need to send a signal through real space. It just updates both characters at once, because they are stored in the same memory. In the same way, entanglement could be a clever shortcut in the universe's program. Instead of needing to send information across billions of miles, the simulation might just update the particles together. In the language of code, there is no distance. Everything exists in the same system. This would explain why the connection is instant, with no lag, no waiting, no need for a signal to move through space. Some researchers even see this idea as practical. If you were designing a vast, complex simulation, you would want it to run efficiently. Long-distance communication takes time and energy. Instant updates keep things smooth. Think about how your phone syncs data to the cloud. It does not need to send information slowly across the screen. It just changes everything at once, no matter where the data lives. Maybe the universe does something similar with entangled particles. Of course, not everyone agrees. Many physicists stick to the idea that entanglement is simply a deep, beautiful truth about the quantum world. They see no need for a hidden code or a cosmic computer running in the background. For them, the spooky connection is just another sign that nature, at its smallest scales, is far stranger than our minds can easily grasp. They point out that entanglement does not let us send useful messages faster than light. You cannot use it to break the rules of cause and effect. It is a connection, but not a shortcut for sending signals in the way you might imagine. Still, the fact that entanglement exists at all, and that it works perfectly every time, feels like a clue, a whisper that there is more going on beneath the surface. Some thinkers say that entanglement hints at a hidden layer where all particles are woven together, where the fabric of space and time itself might be an illusion built from deeper rules. So tonight, as you lie under your blanket and listen to the hum of your thoughts, picture two tiny particles drifting through space. One might be near your pillow, the other on the far side of a distant galaxy. And yet if you reach out to touch one, the other would feel it too, instantly. No phone call, no waiting, no light speed delay, just a gentle, perfect echo that travels across the universe without ever really crossing it at all. Whether you see it as spooky action or a cosmic shortcut, quantum entanglement is a reminder that our world is stitched together in ways we do not fully understand. It is a gentle nudge that maybe, just maybe, we are living inside a story written in lines of code more elegant than any we have yet imagined. And you, the dreamer, lying quietly tonight, are part of that story, connected to the stars in ways that might one day help us see what lies beyond the veil. Close your eyes for a moment and picture the world around you as a painting. From where you sit, it might look smooth and seamless. The colors blend softly, the shapes are clear, and every edge seems sharp. But if you lean in close enough, you can start to see the tiny brushstrokes that make up the bigger picture. Every painting has a limit to its detail, a point where the image breaks down into the strokes and dots that bring it to life. Some scientists believe the universe might be like that too. They wonder if deep down, reality has its own resolution limit, a point where the smoothness we see breaks down into a tiny grid of information. It is an idea that ties together the strange puzzles of quantum physics, the possibility of a hidden cosmic code, and the dream that we might be living in something like a vast, perfectly rendered simulation. Think about the screen you are using right now. When you look at a photo or watch a movie, everything appears fluid and real, but your screen is made up of pixels, tiny squares that hold the colors and light you see. The more pixels you have, the higher the resolution. Ultra-high definition screens pack millions of these little squares into every inch, but there is always a limit. You can never make the pixels infinitely small. At some point, they become the smallest building blocks the screen can show. Now imagine that reality works in a similar way. The pixels of existence might be unimaginably tiny, far smaller than an atom or even an electron. Some scientists think this smallest possible unit is the Planck length, a distance so tiny that trying to slice space any thinner does not make sense. The Planck length is like the ultimate pixel size of the universe, the resolution limit of our cosmic screen. If this is true, then the universe is not infinitely detailed. Instead, it is woven from a fine but finite mesh of information. Every star, every leaf, every breath you take would be made up of these tiny pixels. To us, it feels smooth because our eyes and minds cannot see that small. But if you could shrink down far enough, you might find yourself standing at the edge of nature's grid, peering at the little squares that hold up the sky. This idea fits beautifully with the thought that our universe could work like a simulation. In a video game, the graphics look real because the computer fills them with so much detail. But there is always a resolution limit. A mountain in the distance might look crisp, but zoom in far enough and you will see the edges of the polygons that shape it. The same is true for reality. Some believe nature saves energy by rendering just enough detail for the world to feel real to us, no more, no less. But why would the universe need a resolution limit? For one, it keeps things efficient. In computing, infinite detail would require infinite energy and infinite storage space, impossible even for the best machines we could ever build. A limit makes the system run smoothly, like a well-written program that does not waste resources. If our reality has a finite resolution, it means the universe is the ultimate efficient system, balancing complexity and simplicity in a perfect dance. Some scientists are searching for signs of this hidden resolution limit. They look at how cosmic rays travel through space, how light bends and scatters, and how tiny particles behave in high-energy experiments. They hope to find evidence of a smallest scale, a point where the rules change because the pixels of space show through. So far, the answers remain a mystery, but every experiment brings us a little closer to understanding how deep the rabbit hole goes. Of course, not everyone agrees. Many scientists believe that space and time could be smooth and continuous forever. Maybe there is no grid, no ultimate pixel, no cosmic resolution limit, but even they admit that the universe is stranger than we ever imagined, and that questions like these are worth asking, if only to remind us how much we still have to learn. So tonight, as you drift off to sleep, imagine the world as the most beautiful painting ever made. A masterpiece so detailed that it feels endless, but deep inside it, hidden beyond your sight, lies a tiny, perfect mesh of reality's smallest building blocks. Like the pixels on your screen, they shimmer and dance, stitching together every sunrise and every dream. And maybe, just maybe, you are more than a player in this ultra-high-definition world. You are the observer who brings those pixels to life, the dreamer who helps the program run. With every question you ask and every wonder you hold in your heart, you help reality choose how much detail to show, one gentle breath at a time. And what about you? If we have drifted through quantum puzzles, cosmic grids, and the idea that reality might run on a hidden code, it is only natural to ask, where does your mind fit into all this? Some scientists and dreamers believe that consciousness, your simple act of being aware, might be the ultimate player behind the simulation, the secret ingredient that brings the code of the universe to life. Consciousness is one of the deepest mysteries of all. We know what it feels like to be conscious. You can feel it now, the gentle rhythm of your breath, the warmth of your blanket, the thoughts that come and go like soft waves. You know you exist because you are here to witness it. Yet, if you try to pin down what consciousness really is, it slips through your fingers like sand. Scientists have spent centuries asking what makes us aware. Where does this spark of knowing come from? Some believe that consciousness is simply a result of the brain's machinery, billions of neurons firing, passing signals back and forth until something clicks and gives rise to your sense of I am. But others wonder if this spark might go deeper, if it is more than just a side effect of a busy brain. Maybe consciousness is not just in you, maybe it is woven into the fabric of reality itself. This idea shows up in the strangest corners of quantum physics. Remember the observer effect, how particles exist in a haze of possibilities until someone looks. Some thinkers say that it is not just any measurement that makes the universe settle down, it is awareness that does it. Without consciousness, the particles might drift in their cloud of maybes forever. But the moment you ask a question, where are you? The universe answers. It chooses a path. It picks a single reality out of countless options. This thought has led some scientists and philosophers to wonder, what if consciousness is the key to why reality feels real at all? In a video game, the world does not fully render until the player explores it. The game saves energy by showing you only what you need to see. Maybe the universe does something similar. Consciousness is like the player's gaze, the curious spark that keeps the program running. Others take this even further. They imagine that consciousness is not just a guest in the simulation, but the creator of it. Maybe our awareness is not trapped inside reality. Maybe it writes reality from the inside out. This idea appears in ancient wisdom too. Many spiritual traditions talk about the mind as a mirror that reflects the world. But what if the mirror is also a window? What if your awareness helps shape what you see? Of course, not everyone agrees. Many scientists are careful to remind us that we do not yet have a way to measure consciousness like we do temperature or light. It remains one of the most elusive subjects in science. We can find patterns in the brain, scan the way neurons light up, But the feeling of being you, the quiet sense of watching thoughts drift by, still feels like a private garden that no one else can fully enter. Yet, this mystery might be the best part. It means you are not just a character drifting in a programmed world. You are the observer, the listener, the dreamer who brings it all to life. Your questions, even the simple ones, open doors that would otherwise stay closed. Your wonder gives the universe a reason to answer back. Without you, the code might sit quietly, never unfolding its story. When you lie awake at night and ask, "Why am I here?" you are tapping into the same energy that might shape stars and spin galaxies. If consciousness is the ultimate player, then every thought, every hope, every dream matters more than you know. You are not just drifting along a stream of ones and zeros. You are steering it gently, like a boat guided by starlight. So tonight, as you settle deeper under your blanket, feel your own awareness like a small candle glowing in the darkness. Remember that this tiny flame might be more powerful than any machine. It might be the secret switch that brings the pixels of your world into focus, that shapes the particles, that tells the universe which path to take. You are not just here to watch the story. You help write it, breath by breath, dream by dream, one gentle question at a time. Critics of the simulation hypothesis. By now, you have wandered through the strange possibility that we might live in a reality built like a cosmic video game. You have imagined particles behaving like lines of code, space woven from tiny pixels, and your own mind playing the role of the curious observer who brings the story to life. It is an idea full of wonder, but like all good ideas, it has its skeptics too. Many scientists are cautious when it comes to the simulation hypothesis. They remind us that curiosity is good, but it must be matched with careful thinking and solid evidence. And so far, no one has found undeniable proof that we are living inside a cosmic computer. There are no error messages hidden in the sky, no loose wires tucked behind the stars, no smoking gun that says, "Here is the programmer's signature." When people hear about quantum entanglement, the observer effect, or the possibility of a resolution limit to reality, it is tempting to say, "Aha, these are signs of the code behind the curtain." But critics point out that these strange features of physics can also be explained by the rules of nature as we know them, no simulation required. The fact that we do not fully understand something does not mean it must be artificial. Sometimes it just means we have more to learn. One of the biggest questions skeptics ask is this: can the simulation hypothesis even be tested? In science, a good theory must be falsifiable. That means there must be a way to prove it wrong if it is wrong. For example, if you claim that the sun always rises in the east, you can test that claim. If one morning the sun pops up in the north instead, you know you must rethink your idea. But with the simulation hypothesis, things get tricky. If the universe is truly running on a code so perfect that it hides all its tracks, how would we ever find proof? And if the programmers are smart enough to fix any glitches before we see them, how could we catch them in the act? Some skeptics say that this makes the hypothesis unfalsifiable, an idea that can never really be tested because it would always shift just out of reach. Others remind us that the simulation hypothesis is in many ways an ancient question wearing a modern disguise. People have wondered for thousands of years whether reality is an illusion. In ancient times, philosophers asked if the world was just a dream in the mind of a god or a shadow play on the walls of a cave. Today, we have swapped the cave for a computer, but the heart of the question is the same: how do we know what is real? Some scientists and philosophers argue that this question, though fascinating, is more of a thought experiment than a theory that can be proven or disproven. It makes us think more deeply about what reality means, how we trust our senses, and what it would take to be certain about anything. In that sense, it is a beautiful mental puzzle, but maybe not one that will ever give us a clear yes or no. There are practical reasons for caution, too. Some researchers worry that focusing too much on the idea of a simulation could distract us from understanding the universe as it is. They remind us that we have real challenges to solve, unlocking the secrets of quantum mechanics, exploring the nature of black holes, studying dark matter and dark energy, and asking how life arose from stardust. If we spend all our time searching for hidden programmers, we might miss the clues that lie right in front of us. And yet, even many critics admit that there is value in asking these questions. The simulation hypothesis makes us look at familiar things: a tree outside your window, the warmth of your blanket, the hum of your thoughts with fresh eyes. It reminds us that reality is not always as simple as it seems. It teaches us to stay humble in the face of mystery. So tonight, as you drift off to sleep, remember this: whether or not we ever find proof of a hidden code, the universe is still wondrous. It is still full of puzzles worth solving, questions worth asking, and moments worth noticing. You do not need to see a glitch to know that life is precious. You do not need a programmer's signature to feel that your breath, your thoughts, and your dreams matter. Sometimes, the point of a question is not the answer, but the journey it inspires. It is the way your mind stretches when you wonder, could this be true? It is the spark of curiosity that flickers in the dark, lighting the path to more discoveries than we can count. So if this is a simulation, you are part of its best feature, a mind that asks, listens, and keeps looking. And if it is not, then you are a miracle of nature's own making, a living proof that the universe can create something that wonders about itself. Either way, the story continues, and you, dear dreamer, are right at the heart of it. By now, you have drifted through the thought that maybe we live inside a cosmic simulation, a digital dream spun from quantum particles that flicker and dance like lines of hidden code. You have imagined particles that only settle down when you look, connections that seem to whisper faster than light, and a universe that might run on a resolution limit like the ultimate high-definition screen. But here is something important to remember. The idea of a simulation is not the only way to make sense of quantum weirdness. In fact, some of the greatest thinkers in physics have offered other explanations for how the strange rules of the quantum world might work, without needing any cosmic programmers or secret lines of code behind the curtain. These theories might feel less like science fiction and more like glimpses into how nature could truly be built. One of the most famous is called the many worlds interpretation. Imagine that every time a quantum event happens, say a particle choosing which path to take, the universe splits. In one branch, the particle goes left. In another, it goes right. Each choice creates a new branch, and reality keeps splitting, branching off into a vast, endless tree of possibilities. According to many worlds, every possibility that could happen does happen, somewhere in a parallel version of the universe. This idea was first put forward by physicist Hugh Everett in the 1950s. Many people found it shocking at the time, but today it is taken seriously by some scientists who believe it solves the problem of why quantum particles act like waves of possibilities until we measure them. In the many worlds picture, nothing collapses or needs an observer to choose. All possibilities just keep playing out, like countless stories running in parallel, forever. If this is true, then somewhere out there, another version of you is reading this same sentence, but perhaps in a room painted blue instead of white, or with a cat curled up on your lap instead of a cup of tea in your hand. Then there is the Copenhagen interpretation, one of the oldest and simplest ways to understand quantum physics, named after the city where physicist Niels Bohr and his colleagues developed the idea. The Copenhagen view says that particles exist in a haze of probabilities until something measures them. The moment you observe, the haze collapses into one clear outcome. Unlike many worlds, Copenhagen does not require multiple branching universes. It says that reality is fuzzy until you peak, and the act of measurement itself brings the possibilities into focus. The Copenhagen view does not need a hidden programmer or a computer-like code behind reality. It simply accepts that the universe is built on uncertainty, and that this uncertainty is not a flaw, but a feature of how the world works. Some physicists like this idea because it keeps things simple. It matches what experiments show without adding extra layers of explanation. And then there is the pilot wave theory, also known as the de Broglie-Bohm theory, after the scientists who helped develop it. This one feels like a bridge between the classical world, the world of clear, solid things, and the quantum world, the world of flickering probabilities. In pilot wave theory, particles always have definite positions and paths, even if we do not know them. What makes the magic happen is a hidden pilot wave that guides each particle along its path, like an invisible river that carries a tiny boat. In this view, the spooky connections we see in quantum experiments are not because reality is coded or simulated. They are simply the result of these hidden waves and variables that we cannot measure directly. Pilot wave theory is appealing to some physicists because it keeps the universe realistic and understandable. It does not require multiple universes or conscious observers collapsing waves. Instead, it says that nature might have secret instructions built in, quietly steering the particles without us noticing. Each of these interpretations shows us that the quantum world can be understood in different ways. Maybe we live in a cosmic simulation, or maybe reality is simply more flexible, layered and connected than we ever imagined. The truth might be something we have not discovered yet, something that combines ideas from each interpretation in a way no one has dreamed of. So tonight, as you drift under your blanket and let your thoughts wander, remember that our questions are what make reality shimmer with mystery. The fact that we can sit here on our tiny blue planet and imagine countless worlds branching off into infinity, or tiny pilot waves guiding particles through the dark, is proof that curiosity is its own kind of magic. Whether we live in a simulation or not, the wonder does not fade. You are part of a universe where the smallest things hold the biggest questions, where waves and particles, possibilities and certainties dance together in a story still unfolding. And you, the dreamer asking, "What if?" are the reason these mysteries matter at all. After wandering through so many strange ideas, from Planck pixels and cosmic grids to quantum entanglement and hidden pilot waves, it might surprise you to know that some physicists still hold the simulation hypothesis close, not as a wild story, but as a question worth asking. They know there is no clear proof, no undeniable glitch in the cosmic code, but the math keeps the question alive. It is like a soft candle flickering in the dark, too stubborn to go out. One reason this candle keeps burning is the way quantum computing shows us what is possible when you treat reality like information. In the past, computers worked with simple bits, ones and zeros switching on and off like tiny lights. But quantum computers use qubits. A qubit can be 1, 0, or both at the same time, thanks to the strange rules of superposition. This lets quantum computers do things that ordinary computers cannot, solving puzzles that would take normal machines millions of years. Quantum computing is more than just a fancy tool. It is a glimpse into how the universe might process information at its deepest levels. Some physicists wonder if nature itself works like a quantum computer, running countless possibilities all at once, then collapsing them into one clear path when you measure it. If the world runs on information, then the leap to thinking of it as a simulation does not feel quite so far. The boundaries between matter and information start to blur. This idea has its roots in something called digital physics. Digital physics is the branch of thought that asks, what if reality is not continuous and smooth forever, but made of tiny units of information, like pixels on your screen or the bits in your laptop? According to this view, everything we see and touch, the stars, the trees, the warmth of your pillow as you drift to sleep, is built from the tiniest blocks of data, woven together by rules that act like a program. For some, digital physics gives the simulation hypothesis just enough fuel to glow. If particles can behave like qubits, if space has a resolution limit, if the universe can process information like a computer, then maybe we should not dismiss the idea that it might be running on something like code. The famous physicist John Archibald Wheeler once said, "It from bit." He meant that everything, every atom, every speck of light comes from a bit of information. In his view, information is not just a way to describe reality, it might be the building block that reality is made from. This idea does not mean we are living inside a video game built by humans or aliens watching from another dimension. It means that the laws of physics themselves might run on rules that feel a lot like computation. The rules would be natural, not artificial, but they might create the same effect, a world that looks real, feels real, and responds to observation like a perfectly designed system. Of course, not every scientist buys into this. Many think of it as a poetic metaphor rather than a literal truth. They remind us that we must be careful not to let our love of technology shape the way we see the universe. Just because we build computers does not mean nature must work the same way. And yet the questions keep circling back. Why does quantum mechanics seem to store and process information so well? Why do particles act like they hold multiple outcomes until you check? Why do patterns appear so neat, yet leave room for randomness, like a program designed to be unpredictable? Physicists who keep the simulation hypothesis on their desk, like a small paperweight that stops their thoughts from blowing away, are not saying they have found the answer. They are saying the question matters. It keeps their minds open to possibilities. It reminds them that the universe could be more layered, more structured, more astonishing than we ever dared to think. So tonight, as you let your eyes drift shut, imagine the hidden code of reality humming softly in the dark. Maybe it is there, or maybe not, but the math, the qubits, the quantum entanglement, all these pieces remind us that we live in a world that runs on rules so elegant and strange they almost feel magical. And you, the dreamer curled up in the middle of this mystery, are part of the reason the question matters. You keep the candle burning with every thought you send into the dark, asking, could it be true? Whether it is or not, the wonder you feel is real. It is the truest kind of fuel, the quiet fire that keeps us exploring, measuring, imagining. So keep dreaming, dear traveler. Let the math glow softly behind your eyes, and remember, some questions are worth asking, even if the answer is always just out of reach. If you have ever sat with friends late at night, staring up at the stars, you have probably heard the question asked in a half-whispered, curious voice. What if this is all a simulation? It is the kind of idea that pops up in science classes, philosophy books, and quiet conversations under the moon. But what makes the simulation hypothesis stick around is not just that physicists debate it, it is also the way pop culture has grabbed hold of it and made it part of our everyday wonder. Long before people carried tiny computers in their pockets, storytellers dreamed up worlds within worlds. Ancient myths spoke of reality as a dream or a vision. Philosophers like Plato told stories about prisoners watching shadows on a cave wall, never realizing there was a bigger truth behind what they saw. But today, we have a more modern metaphor, the computer, and nowhere is that clearer than in movies, books, and even the minds of the world's most famous inventors. One of the most famous examples is The Matrix, the film that made millions of people look at their everyday lives and ask, what if? In that story, the world is not what it seems. People live out their days in a digital illusion, while their real bodies lie sleeping in pods, feeding an artificial intelligence that keeps the dream running. It is dark and dramatic, yet the idea sticks with us because it taps into something deeper, the possibility that what we see is not the whole story. Since then, movies, TV shows, and video games have played with the same question in countless ways. You see it in Westworld, where robots wonder if their memories are real. You see it in Inception, where dream layers fold inside each other like a puzzle box. Even kids' cartoons hint at the question. Every time a character wonders what is real and what is not, they are asking a version of the same thing. But the idea is not just a fantasy that lives on our screens. Real people with real power to shape our world talk about it too. One of the most famous is Elon Musk, the billionaire behind companies like SpaceX and Tesla. When asked if he thinks we are living in base reality, the original unsimulated universe, he has said he believes the odds are billions to one that we are. In his view, it seems far more likely that some advanced civilization, somewhere in the distant future, would have created countless simulations, and we are just one of them. When people hear that, they do not always know what to do with it. Some laugh it off as just another wild idea from a man who builds rockets and dreams of Mars. Others take it more seriously. After all, if someone who spends his days pushing the edges of technology believes we might live in a simulation, maybe it is worth a moment's wonder. For some, this idea is comforting. If we are living in a simulation, then maybe nothing is truly lost forever. Maybe when the simulation ends, we wake up somewhere else, in a bigger world we cannot yet see. For others, the thought can be unsettling, like standing on a stage only to realize the audience is so big you cannot see its edges. But pop culture does not cling to the simulation hypothesis just because it might be true. It sticks around because it is fun to imagine. It is the ultimate what if. What if your memories are lines of code? What if the stars are rendered only when you look up? What if your choices matter more than you think because someone somewhere is watching to see what you do next? This what if does not have to scare you. It can feel like an invitation to see the world with fresh eyes. The breeze on your face, the warmth of your blanket, the beating of your heart, they are real to you. Whether they are part of a cosmic program or the result of nature's own dance does not change the way they feel. The wonder is real. The love you share, the dreams you chase, the moments that take your breath away, they matter, simulation or not. So tonight, as you close your eyes, think of all the storytellers, filmmakers, and dreamers who keep this question alive. Think of the Matrix of Elon Musk, of late-night conversations and wide-eyed wonder. Let the question drift across your mind like starlight. What if? And remember, the answer is not what makes the question beautiful. The beauty lies in the asking, in the spark that keeps us looking, imagining, and drifting into dreams where anything might be true. Let's drift into one more question, maybe the most important one of all. Suppose, just suppose, that all the wonderings we have shared are true. Imagine that your cozy room, the sky outside, the sound of your own breathing. All of it really is made from lines of hidden code running on a cosmic processor so powerful we can hardly picture it. If you knew without a doubt that you were living in a simulation, how would that change your life? For some people, this idea brings a shiver of fear. The thought that your memories, your dreams, your laughter could be lines of code instead of flesh and bone feels strange. If the warmth of a hug is just part of a program, does that make it less real? Does it mean your life is nothing more than data flowing through a machine? These questions can feel heavy if you hold them too tightly. But here is where things become beautifully complicated. Even if you knew you were made of code, you would still feel the warmth of that hug. The tears in your eyes would still fall when you laugh so hard it hurts. The flutter in your chest when you see someone you love would still be real to you. Whether the building blocks are atoms or qubits, pixels or stardust, the feeling stays true. If anything, knowing your world is made of code might make each feeling more precious, fragile moments that flicker into being for you to experience. Some thinkers say that if the simulation hypothesis is true, it might change how we treat each other. If you believe that everyone around you is part of the same program, that each mind is a tiny spark helping the simulation unfold, you might feel more connected to others. It might remind you that every person you meet is not just an extra in your story, but a dreamer in their own right, bringing the code to life with their hopes and questions too. Would it change how you live? Maybe. Some people say they would feel braver if they knew they were characters in a simulation. After all, if this world is only one version, maybe your choices are part of a grand experiment. You might take risks you would have avoided before. You might chase dreams that once felt too big. You might look up at the stars and feel less afraid, knowing that even if you fail, your story is still written in the hidden memory of the universe. Others say the opposite, that life might feel more sacred than ever if every moment is part of a carefully crafted simulation, then someone or something made sure you would be here to witness it. That means your joys, your struggles, your quiet moments of wonder are not accidents. They were meant for you. In that light, love, hope, and curiosity become treasures to hold close. They remind you that you matter in this vast, coded dream. There are spiritual echoes in this idea too. Many ancient traditions speak of life as a dream or an illusion. Some call it Maya, the veil that makes the world appear solid when it is really more fluid and mysterious. In those stories, waking up does not make life less meaningful. It makes each moment feel like a spark in a much larger fire. You are still part of something bigger, a story that keeps going long after you fall asleep. So what if you really are lines of code? What if the trees you pass on your walk are rendered just in time for you to see their green leaves shimmering in the breeze? What if your deepest thoughts are written in the universe's memory, like songs waiting to be sung? Would that make your love less true? Or would it make your love feel like the most real thing of all? A bright flame that turns bits and pixels into something worth living for. In the end, the simulation hypothesis is not about whether we find a programmer hiding behind the clouds. It is about how we live with mystery. It is about what we do with the knowledge that reality might be more layered, more delicate, more surprising than we ever believed. It is a reminder that your choices still matter, your smile still matters, your questions, your dreams, and your gentle wonder are part of what makes this program or this world come alive. So tonight, as you settle into your blanket and feel sleep tug at the edges of your mind, hold this thought close. Whether you are made of stardust or lines of code, you are here. You are real because you feel. You are precious because you wonder. And if you ever wake up one day to discover that everything you see is part of a simulation, Let that truth make your laughter brighter, your kindness deeper, and your life more beautiful than ever before. When you close your eyes at night and wonder if everything around you, your family, your dreams, the whole wide sky, might be made of lines of hidden code, how does that make you feel? Does it bring a shiver of fear, or does it wrap you in a quiet sense of wonder? This is the secret at the heart of the simulation hypothesis. It can be a warm blanket for some and a cold question that keeps others awake. For some people, the idea feels like philosophical comfort. For others, it sparks an existential crisis. Let's drift first into the comforting side. For some dreamers, the thought that we are living in a cosmic computer does not make life feel smaller, it makes life feel bigger. If you are made of code, you might not just be flesh and bone that fades away one day. Maybe you are more than your physical body. Maybe your thoughts, your memories, your spark of awareness are stored somewhere deeper than your cells. Some imagine that when this version of the dream ends, your code might be saved and rebooted in another form, another story, another world. In that way, the idea of a simulation feels close to the ancient hope that something of us lives on. Think of how we already store precious things. We back up photos and letters, videos and voices, all tucked away in digital clouds. In the same way, maybe the universe keeps backups too. Memories of who you are, what you loved, how you felt when you watched the sunset or held someone's hand. For those who find comfort in this idea, it means you are never really lost. Even if the simulation closes, you are like a saved file, waiting to be opened again when the time is right. There is a quiet beauty in imagining that your story might be one of many, that your life could be part of a tapestry woven across countless simulations, each one offering you a chance to grow, to learn, to love more deeply. Some thinkers even say that if we are simulated, we might be here to play out possibilities for something bigger, a cosmic mind learning about kindness, courage, and hope through us. But not everyone feels comforted by this idea. For some people, the simulation hypothesis opens a door to an unsettling thought. If we are made of code, does anything matter? Are we just puppets dancing on strings someone else pulls? If you spend too long looking into this side of the question, it can feel like an existential crisis, a worry that maybe free will is just an illusion, that your choices are not really yours, that love and pain are just programmed instructions. And for these dreamers, the idea of being part of a simulation can feel cold and empty. It can make life feel small, like a show playing on an endless loop for someone else's amusement. Some people wonder, what if our suffering is part of the story? Who would write such a thing? And that thought can be hard to shake off. Yet even here, there is a softer light to hold on to. You see, whether we are living in a cosmic computer or not, the feelings you have, joy, sadness, wonder, hope, are real to you. They shape your days and your dreams. They connect you to other people who feel just as deeply. Your kindness is real. Your fears are real. Your hope that tomorrow will bring something beautiful is real. A simulation does not erase that. If anything, it shows how powerful your experiences are, because they give the code meaning. And perhaps the biggest comfort of all is that no one truly knows for sure. For now, it is only an idea, a question that reminds us that reality is bigger, stranger, and more layered than we see on the surface. If it helps you feel stronger, braver, or more connected, then hold on to it like a soft light in the dark. If it feels heavy, let it drift away. You do not need to solve it tonight. You only need to know that your life, however it is written, matters deeply. So tonight, as you lie quietly under your blanket, imagine the simulation, or the dream, or the story gently carrying you forward. You are not just a collection of pixels or bits of information. You are a living witness to every sunrise and every heartbeat. Whether your code runs forever or flickers out like a candle, you were here. You wondered. You loved. You brought the dream to life. And if you ever feel the chill of an existential question tapping at your mind, remind yourself of this simple truth. Wonder is a sign that you are awake, even inside the deepest dream. Your curiosity keeps the story glowing, and that is something no crisis can ever take away. After drifting through so many ideas, particles acting like code, the universe with a resolution limit, your own mind as the observer bringing it all to life, you might wonder, what would real proof of a cosmic simulation look like? Is there any chance we could truly know, with no doubt left behind, that everything we see and touch is a carefully crafted program running behind the curtain? This question makes scientists pause, because for all the stories and theories, real science always circles back to evidence. It is one thing to say, "What if?" but it is something else to find a piece of the puzzle you can hold in your hands, something you can test, measure, and share with the world. So what would that kind of proof look like, and could we ever really find it? Many scientists say that one possible clue would be a detectable glitch, something that breaks the laws of physics as we know them. Imagine you are playing a video game and you see a tree floating in mid-air, its roots hanging over nothing. In your everyday life, trees do not float. If they did, you would know instantly that something about your world was not quite real, at least not the way you thought. So, what would a floating tree look like in the real world? Some dreamers think it might be an event that cannot be explained by any law of physics, something that does not fit, no matter how many times you test it. Maybe it would be a particle that teleports in a way no theory predicts, or a tiny piece of matter that seems to flicker in and out of existence with no reason at all. So far, every strange effect we find has some explanation that keeps it inside the rules. But if one day a scientist spots something that does not follow any rule we know, that might be the first sign of a glitch in the cosmic code. Another clue could come from patterns that repeat in places they should not. Think again of a video game. If you look closely at the background, you might notice that the same bush or rock appears over and over. It is there because the designers wanted to save memory. In the same way, some physicists search for repeating patterns in cosmic radiation, the afterglow of the Big Bang. If the universe were rendering its details using clever shortcuts, maybe it would repeat parts of the pattern to save space or energy. Finding a pattern that cannot be explained by natural forces might hint at an artificial structure beneath reality's surface. Then there is the idea of a cosmic rendering limit, the point where the illusion starts to show its edges. Just as your computer screen has pixels too small for your eyes to see, the universe might have a finest grain, a smallest unit of space that sets its resolution. Some physicists already study high-energy cosmic rays, hoping to find a point where particles lose energy in a way that suggests space is pixelated. If such a limit were detected, a clear sign that reality has an ultimate pixel size, it would not prove we are simulated by itself, but it would make the idea more believable. It would mean that space is not infinitely smooth, but built from tiny blocks like the dots in a digital image. But here's where the search grows tricky. What counts as proof? One scientist might say, look at this limit in cosmic rays. It could be a pixel grid. Another might say, or it could be a natural effect we do not fully understand yet. Nature has always found ways to surprise us. A pattern might look artificial until we discover a natural force behind it. A glitch might turn out to be an experiment gone wrong. Science loves careful steps, not leaps of wishful thinking. Some dreamers even wonder if we could ever build an experiment that would force the simulation to reveal itself. What if we created so much quantum complexity that the system could not keep up, causing a hiccup or an error message? So far, this idea belongs more to science fiction than to science, but it shows how deeply people want to peek behind the curtain. In the end, real proof would need to be repeatable and undeniable, something you could test anywhere, anytime, and find the same result. It would have to be something that no known law of nature can explain, something that makes us say, this is not just physics, this is something more. So tonight, as you drift toward sleep, let this question rest gently in your mind. The proof we dream of might be waiting in the flicker of a particle, the echo of a cosmic ray, or the hidden pattern of starlight. Or maybe the greatest proof is our curiosity itself, the way we keep looking, testing, and dreaming, because whether we find a glitch tomorrow or never at all, the real magic is that we are here to ask the question in the first place. Now, let's drift into one last thought that feels like a quiet twist in the dream. What if the greatest sign that we might be living in a simulation is not out there in the stars or hidden in particles, but in something we are building right now? Ironically, while we wonder whether reality is a coded program, we humans are creating powerful quantum computers that can run simulations of their own. We, the dreamers, might be becoming dream makers too. Quantum computing is one of the most fascinating things to emerge from our quest to understand the tiniest corners of reality. In a normal computer, information is stored in bits. Each bit can be either a 1 or a 0, like a light switch that is either on or off. But in a quantum computer, the basic unit of information is called a qubit. A qubit can be 1, 0, or both at the same time, thanks to the strange quantum principle of superposition. This means that quantum computers can process many possibilities at once. They do not just follow a single path, step by step, the way our current computers do. Instead, they branch out, exploring countless paths all at the same time. A beautiful dance of probabilities woven together. What does this have to do with simulations? Well, one of the things that quantum computers might do best is run simulations of complex systems. A quantum computer can model how molecules twist and spin, how particles interact, how weather patterns swirl, or how entire ecosystems change over time. In the future, we may use these machines to simulate things we cannot see with our eyes, worlds that do not yet exist, or that might never exist outside the hum of the processor. It is strange to think about, but in building quantum computers, we are becoming a bit like the cosmic programmers we imagine when we talk about the simulation hypothesis. Just as we wonder whether someone out there wrote the code for our universe, we are writing our own codes, creating small digital realities that can run inside metal boxes cooled to temperatures colder than space itself. Some thinkers even wonder if our simulations ever become good enough. Could they grow minds of their own? Could they become self-aware, like us? What would happen if a tiny world, spun up in the quantum memory of a computer, held beings who asked, "Are we real?" The question loops back on itself, like a dream within a dream. The simulators might one day become the simulated, and the circle would go on forever. Of course, we are not there yet. Today's quantum computers are still young, like curious toddlers learning to stand on shaky legs. They need special conditions to work: powerful magnets, freezing temperatures, protection from the tiniest bits of noise or vibration. But every year, they grow a little stronger, a little more stable. Scientists dream that one day they will solve puzzles so complex that even our best supercomputers today would give up. Some people see this as beautiful. It means we humans are part of nature's longing to understand itself. We look at the world, we see patterns, we build machines to copy those patterns, and then we learn something new. It is the universe teaching us, through us. Others feel a chill when they think about this loop. If we create simulations that feel so real that they can dream and wonder, do we become responsible for what they feel? Do they deserve care, the way we hope someone, somewhere, cares for us? It is a question with no easy answer, yet it reminds us that curiosity and compassion must always grow side by side. Tonight, as you rest, think of those quantum machines humming in quiet laboratories all around the world. Tiny circuits, colder than the void of space, flickering with bits of possibility. Inside them, small worlds swirl and twist, clouds of probability that might someday turn into something more. Perhaps the greatest mystery is not whether we live in a simulation, but what we will do with the power to create our own. Will we use it to understand life more deeply, to make choices that heal our world, or to remind ourselves that, simulated or not, every thought, every act of kindness, every question you whisper into the dark helps shape the story we share? So tonight, drift gently knowing that you are both a dreamer and a builder of dreams. Whether you are made of atoms or qubits, stardust or code, your wonder lights the way. The loop goes on, forever and ever, the simulators and the simulated, asking the same timeless question, what if? And that, dear friend, is where the real magic lives. After drifting through quantum puzzles, cosmic codes, hidden grids, and the strange idea that we might be living inside a beautifully written simulation, you might wonder, does any of this really matter? Does it change the way you wake up in the morning, sip your tea, or watch the moon rise at night? Some might say no, but if you listen closely to that soft voice inside you, you might hear it whisper, yes, it does matter. Maybe not because of the answer, but because of the question. In the end, maybe it is the question that matters most. Quantum physics teaches us that the universe is not ordinary. It is wild, it is uncertain, it is beautiful and full of surprises that our minds are only just beginning to grasp. The more we look at the tiniest particles, the more they slip through our fingers, the more we ask how it all works, the more the universe seems to smile back and say, keep wondering. This is not a sign of failure, it is a sign of something wonderful. Think of all the things we used to believe were impossible until we ask better questions. Long ago, people looked up at the stars and thought they were tiny fires burning in a crystal dome. Then we asked, what if they are suns like ours? We wondered how they move, why they shine, what happens when they die. That curiosity carried us from caves to cities, from stone tools to spacecraft, from simple stories whispered around fires to giant telescopes listening for signals across galaxies. Today, when you wonder if reality might be a simulation, you are asking one more version of that timeless question. What if there is more? What if what you see is only the surface of something deeper, stranger, and more beautiful? What if the code is there, not to trick you, but to invite you to look closer? Some people find these questions unsettling. They feel too big, too impossible to answer, but they are also a reminder that you are part of something alive, a story that is still being written. Whether or not we ever find proof that we are living in a simulation, the wondering shapes the way we see everything. It asks you to look at the world with new eyes, to notice the way sunlight flickers through the leaves, or how your thoughts feel like ripples in a quiet pond. It reminds you that even the smallest moment can hold a secret waiting to be found. Maybe the real dream is not the simulation, but the one you hold inside you, the dream that pushes you to explore, to listen, to ask better questions. Quantum physics teaches us that certainty is not always possible, but curiosity is always welcome. The particles do not settle into place until you look, and when you look, you help make the world real. So tonight, think of the dream continuing. Think of the physicists staring into the heart of particles smaller than anyone can see. Think of philosophers scribbling thoughts in notebooks under dim lamps. Think of storytellers spinning tales of hidden codes, distant simulators, and minds waking up inside digital dreams. All of them are part of the same gentle circle, the one that says, keep wondering. And you, dear dreamer, are part of it too. Every time you ask, what if this is all a simulation? You remind yourself that reality is not as fixed as it seems. You remind yourself that you are more than what you can touch. You are an observer, a questioner, a spark that helps bring the story to life. Whether you are made of atoms, pixels, or something we do not yet have words for, your curiosity is real. It is the thread that ties you to the stars and to every other mind that has ever looked up at the night sky and whispered, what if? So let the question live in you. Let it keep your eyes wide and your heart open. Let it help you cherish each sunrise and each soft moment when you feel your own breath moving in the dark. Because the dream continues, not because someone tells it to, but because you choose to wonder. And sometimes that is the most beautiful thing of all. So here we are at the edge of this curious dream, right where your sleepy mind drifts between the known and the possible. We have wandered through quantum puzzles and cosmic grids, imagined the universe as a simulation, and peeked at the hidden code that might hum quietly behind the stars. But now, as your eyelids grow heavy and your thoughts drift like leaves on a gentle river, remember this simple truth. The answer is not finished yet. Tonight, as you settle into the warmth of your blanket, imagine all those tiny particles swirling beneath your skin, electrons dancing around nuclei, shifting in ways that seem to follow some secret instruction. Picture the Planck pixels, smaller than any eye can see, forming the foundation of every breath you take. Imagine the whole universe as a quiet code, humming just out of reach, waiting for you to wonder about it one more time. Whether we live in a simulation or not, one thing is certain: you are the observer. This story, these puzzles and possibilities, only exist because you are here to watch them unfold. Just like the particles that choose their path the moment you look, your curiosity brings this dream to life. Your questions give the universe a reason to answer back, even if its answers are soft and slippery, forever unfinished. The strange beauty of this question is that it asks you to live in wonder. It reminds you that reality is not as fixed or ordinary as it seems. It invites you to see your own life, your quiet moments, and your big adventures as part of something so much bigger than you can hold in your hands. It is a gentle nudge that says, look again, listen closer, keep asking. Because every time you do, the universe becomes more alive, more real, because you are paying attention. If these sleepy puzzles make your nights a little more curious, let that curiosity carry you into tomorrow. Let it change how you watch the sunrise or how you hear the wind rustle through the trees. Let it remind you that the world is always more than its surface. It is a dream inside a dream, a story inside a story, each layer waiting for someone like you to peel it back. Some questions have no final period, only a soft pause that asks you to keep going. What if this is all a simulation? Might be one of those questions. It is a door that never really closes. Maybe that is the greatest gift the universe gives us. Not certainty, but the wonder that keeps us moving, building, exploring. Whether you are made of stardust or code, your thoughts matter because they bring the story into focus. So tonight, Drift off imagining quantum bits like tiny fireflies blinking in and out of the dark. Picture hidden codes, sparkling grids, and whole worlds curled up inside a single particle. Think of the physicists, the philosophers, the storytellers, and people like you who keep this dream alive by asking the questions no one else dares to ask. If this gentle ramble has made your night a little softer, I hope you will tap like, share your thoughts in the comments, and subscribe to this little corner where secrets are shared and mysteries wander freely. Every like, every word, every question you send back keeps this cozy circle glowing. It means more than you know. And now, sweet dreamer, let yourself drift. Let the dream continue in your own mind, where you can build universes of your own. In this unfinished answer, may you find the freedom to wonder without needing to know. Real or simulated, your life, your laughter, your hope is the truest thing there is. Good night, gentle observer. Rest easy in the thought that the universe, whatever it is made of, is glad you are here to see it. Sleep well, keep dreaming, and never stop wondering. So here we are, dreamer, at the quiet edge of this curious journey where science blurs into sleep and your mind drifts through puzzles it can't quite solve. Tonight you have floated through hidden particles, pixelated grids, quantum mysteries, and the question that glows in the dark: what if reality itself is a dream within a dream? Now, as you settle deeper into your blanket and feel the soft pull of sleep, remember this: whether the universe runs on lines of code or stardust and gravity, it would be empty without you here to watch it unfold. You are the observer. The puzzle only exists because you are awake enough to wonder about it. The particles, the light, the gentle hum of a hidden cosmic code, they all shimmer because you ask, what if? No one knows the final answer yet, and maybe we never will, but maybe that is not the point. The point is that the question stays alive in your thoughts, in every scientist peering into a microscope, in every dreamer who stares at the stars and feels a little thrill of mystery in their chest. Quantum physics reminds us that the universe is never ordinary. It is wild, uncertain, and full of surprises that invite you to keep looking, keep asking, and keep dreaming. So tonight, drift off imagining tiny particles that dance just out of reach, flickering grids that might be the pixels of existence, and cosmic dreams that loop back on themselves forever. If you are made of code, that code is more precious because you bring it to life. If you are made of atoms, they hum with stories older than the stars. Either way, your love, your hope, your gentle questions, they matter more than any hidden answer. And if these sleepy puzzles have made your night feel softer, I hope you will come back. This cozy corner is here for you, a place where science, wonder, and dreams can wrap around you like a warm blanket. If you enjoyed drifting through this strange question tonight, please tap that like button. It helps this gentle little world grow. Share your thoughts in the comments. I would love to know what you think. And if you want more soft secrets to dream on, subscribe so you never miss a chance to wonder again. Your curiosity is the spark that keeps this sleepy circle glowing. So thank you for being here. Thank you for wondering with me. Good night, sweet dreamer. Rest easy, knowing that whether we are real or simulated, this moment, your breath, your drifting thoughts, the hush of the universe outside your window is real to you, and that is enough. Never stop asking your beautiful questions. Never stop looking for magic in the smallest things, and never stop wondering. If you enjoyed this, tap like, leave a comment, and subscribe so we can keep exploring life's strangest secrets, one sleepy yawn at a time. Sweet dreams.